可以听到。
好的。
那我们开始吗 ？We gonna start?
Let's give a minute while more people join in now.
All right.
For those of you who just joined, please give a second. Let's wait 1 minute for people to join. And if you're interested, please scan our QR code of the WeChat and the Twitter to follow our NACAN, and then you will get more update information. And also, if you have friends who are interested, please share the Zoom link to invite your friends to join right now. Can you see the video, Dr. Fang?
Yeah.
Okay. And also the mouse can show here. Okay. Professor Chen, what do you think? Shall we start?
Go ahead. I think it's time.
Sounds good. Dr. Fang.
All right. Thank you. Hello, everyone. Good evening or good morning. Thanks for making your time to join our section, Agriculture and Food Production for Healthy Life, that is hosted by Dr. Xu Lei and myself. I'm Yong from College
Recording
of
in
Food Science
progress.
and Engineering at Nanjing University of Finance and Economics. It's my pleasure to serve as organization committee for this symposium. On behalf of the organization committee, I highly appreciate the speaker's great input for our section. Hope our audience will enjoy and benefit from the whole section. Now, let us start with a welcome speech by Dr. Xu from National Healthy Science. Please, Dr. Xu.
Thank you, Dr. Fang. Good evening and good morning to the friends in Asia. Welcome to the 4th NACAN Summit Frontiers in Nutrition Joint Symposium of 2022. And this section is the Section 3, Agriculture and Food Protection for Healthy Life, with 3 satellite sections at the same time. And it's my privilege to host with Dr. Yun Fang. I'm Shelley Xu, Principal Scientist at Nestle Health Science in US. And it's a great honor to have this section with you guys. And for those of you who are not familiar with NACAN or have missed the past two sections yesterday, this is the fourth NACAN Summit Frontiers in Nutrition Joint Symposium of 2022. And the joint symposium will serve the mission of the North America Chinese Association for Nutrition and several Chinese parties, which are included, provided platform for networking, collaboration, and scientific exchange among nutritionists, dietitians, food scientists, and other scientists and professionals across discipline health or the life science from NACAN and Chinese partners, including researchers, grad students, professionals, and policymakers, etc. And the topics are broadly defined and relate to food science, food system, food security, nutrition science, from the basic to translational or clinical nutritional epidemiology. And this section, we will focus on the food and nutrition. And the pandemic has accelerated the food industry's need to adopt technologies that will help address glaring structural inefficiencies. Additionally, consumers are more focused on their food and healthier life than ever before. So as a result, the demand for already predominant trends such as immune health, healthy diets, which will intensify in a post-COVID scenario. And the connection between food science and human nutrition is strongly connected in everyone's daily life. And the food is rebuilt from farm to table, and this process will have a significant impact on the bioavailability, nutrition of the food. Hence, this section will help you establish a healthy life with the knowledge that the speakers to share today. And today, our section is also co-hosted by Chinese Association of Food Science. Let me try to show the agenda of today. And this is the agenda, and I hope you will find a lot of interesting topic. And we have a lot of very famous speakers to give us a talk. And please till to the end, because we will have a door prize and Q&A section. And also during the talk, and if you have any questions, please leave the chat of your questions, and we will address at the end of the presentation, each presentation. Now, please allow me to introduce more about the CAFT. So as you can see from the slides, CAFT is a short of Chinese American Food Society. And the Chinese American Food Society was founded in 1975. CAFT has now grown to more than 250 members, and this number is keep growing and engaging in various aspects endeavors of food science and technology across academia, industries, business, and governmental agencies. And the objective of this society is to bring together professionals who are interested in the Chinese culture to stimulate, encourage, and foster the progress and development of food science and technology worldwide. And we do have each year a different community in different world to serve the community. We have also student committees. So for those of you who are professors in academia or students, please encourage your students or friends to join. And you can see the WeChat group, which is hosted by a very famous food scientist professor. And also we have student WeChat group. So sorry, I won't be able to pause for too long, but if you're interested, you can mention in the WeChat and I will give the WeChat code to you. And the next slide, it's our great pleasure that this year, NACAN and CAFT host a very interesting joint webinar, which our clicks of attendees is more than 30,000. And the topic is focused on the personalized nutrition and ultra-processed food. So we invited speakers who are interested in the personalized nutrition and also the calves who are more familiar with ultra-processed food. We discussed this and it's a great success. And we will continue this kind of joint webinar and to share more topic regards to food and nutrition. And also, this is the detail, and please feel free to scan. This is my WeChat if you're interested to know more. And then I will officially hand this over to Dr. Fang. Dr. Fang, floor is yours.
Thank you, Dr. She's opening speech. All right, let's move the first presentation from the Dr. Yao. Dr. Yao is Associate Professor of Food and Nutrition at Florida State University. Dr. Yao's research interest lies in the utilization of chemistry, especially immunochemistry and physiological chemistry as a tool for answer questions arise in both food safety and quality discipline. He is currently an editor of Food Control and editorial board member of LWT for Science and Technology Foods. Okay, please welcome Dr. Yao. Please share your screen and slides with us. Thank you.
Okay, can you hear me?
Yes, Dr. Yao.
Great. Let me open Zoom. Let me share my screen. Okay. Now I'm sharing. Can you see my screen?
Yep, loud and clear.
Wonderful. So let me see where I can use. Okay, I can use the pen, right? Okay. So good morning, good evening, everyone. So today I want to present something related to in vitro characterization of soy agglutinin. Basically, this is an anti-nutritional protein, which we studied for a few years now. Let's go ahead. So basically, you can see this is the trend of global market of plant-based protein. So here has several key information I want to share with you. Basically, you can see here global plant proteins is basically from within these 10 years keep increasing. So about 8.5% every year. I don't know if you guys can see my marker. Can you see that?
Yes.
Thank you. So another thing is I want to share with you global soy protein. Every year increase about 9%. So compared to 2017, this is 2017. So increase about 28% last year. So related to two big countries, US and China, that's the current information. So you can see China is about 10% increase every year. So why plant-based protein increase so significantly? Because you can see this lovely picture related to plant-based meat. Basically, this is a meat analog, so use a lot. So actually you can see here, this is two very impressive numbers, increase several hundred times. So related to, okay, let me go to the next one. So related to the application. So you can see basically about 90, oh, I need to clean this. Okay, so how to clean this? Remove, clear. All right. So related to the usage. So basically you can see more than 95% used for plant-based protein used for food or animal feed. So related to source, more than 65% is from soy protein. So this is the current situation related to plant-based protein marketing information. So these two pictures show last year's information. So now related to my presentation today. Basically, I want to discuss about soy agglutinin. In short, that's a SBA. So also known as a soybean lectin. So from nutrition side, everybody knows lactate. But let me discuss a little bit more. So actually, soybean lectin itself occupies about 3% deep-fat soybean flour. If we convert this one to soy protein, it's about 6 to 10%. So that's quite a lot. So in general, native form, there's a 4 monomeric subunits. So you can see from these 3-dimensional structure. So 3. So this is a monomer, basically. So about 30 kilodalton. 4 of them, 1, 2, 3, 4 of them here. So also this protein actually is also glycoprotein through glycosylation. So basically you can see here, so this is carbohydrate covalently linked to this monomer. So you can see here several there. Actually it's 4, each subunit. Also, this protein is a metalloprotein, so contains 2 ions, calcium and magnesium. So this is the general information related to soybean lectin. So related to other properties, this is a non-immune protein. So another one is immune protein. Everybody knows that's antibody. So for example, you got a vaccine, so you generate antibody to protect us during COVID-19 pandemic. But this is a non-immune protein. So the purpose in seeds, legumes, plants, the purpose is to protect from predator attack. Let me, for example, if somebody, insects, eat these seeds, my gut toxic, might die. So this is a protection. The basic mechanism, basically just because this is also a carbohydrate binding protein. So basically this can bind to side chain. Let me use this pointer, I think it's a little bit better. So it's bind to this side chain, carbohydrate, not like not like antibody can bind to protein. This one bind to a carbohydrate, specific to 2 sugars, acetylgalactosamine. This is the structure here, and then galactose. So you can see from here, the anti-nutrient mechanism. I want to share the next slide. Basically, Dr. Qin from Jilin Agricultural University recently published several papers, tried to explain the anti-nutritional mechanism of this lectin. But to be honest, since we purified this one in no more than 100 years ago, and the fully understand about the anti-nutritional mechanism still not that clear. Okay, but Dr. Qin has published several papers within these 3 years. But related to the syndrome, when eat these kind of lectin, so have acute syndrome include, okay, nausea, vomiting, diarrhea. If a long-term intake, this kind of lectin can increase cell turnover, gut hyperplasia, or even weight loss. So basically, this is the image I adopt from one of the publication. So mention about at least three aspects about this mechanism here. So basically, you can see this is a small intestine. So this is related to, just like previous, bind to carbohydrate first. So that's tiny villi. So there's a surface protein contain carbohydrate. Second, can inhibit immune system response. Last one, see, this is go to a colon, can interferes with microbiota interaction here. But this is general. But one thing, why this one can happen here? So here is mentioned a keyword, undegradable SBA, soybean lectin. So this is the in vivo mechanism, very general. If you want to know more, please refer these two publications. But related to another one, that's called hemagglutination of this kind of lectin. So the purpose, you can see this is it could be in vivo or in vitro. So related to in vitro, I give you an example here. Basically, that's a reaction that causes clumping of red blood cell. So this is the blue dashed line, that's a negative. Red dashed line, that's a positive. For example, this is a lectin, red blood cell. Okay, you will see if this is a bioactive one, you will see a lattice structure. You can see here, this is a microplate. So you will see the wall, basically it's just like build a network. But if this is a negative, under gravity, red blood cell will precipitate on the bottom. Okay, just like see, we will not see easy to differentiate that. So this is how we verify bioactivity of this kind of poison. So compared to these two mechanisms, so where we can identify this undegradable soybean lectin. But in general, okay, soybean lectin is a thermolabile protein. So that means it's not thermostable. It can be destroyed by heat. However, still, you can see animal feeds, right? We feed cattle. Okay, we feed some poultry, for example. Another thing is, if we did not pay attention, maybe also in our human food, undercooked soybean or uncooked soybean. So this is a publication mentioned about hemaggglutinating activity. So during heat treatment, you can see different temperature from 60 to 100 degrees. You can see the HU activity decrease as a function of heating time, as a function of heating temperature. Another thing is basically from this publication mentioned about is relative heat resistant. That means when we eat beans, no matter what kind of beans, we might need to cook thoroughly. The next one, okay, the source, that means undigestible SBA, soybean lectin, because this protein is digestive enzyme resistant protein. So here you have two studies. Basically use animal studies we can verify. So one is pig, another one is rat. Both are mammalian, just like us. You can see, still can identify 60% of soybean lectin remain immunoreactivity in the small intestine. So here you can see functional lectin still remained in small intestine. So basically from this study, all these kind of studies did not mention about structure information. It's monomer or tetramer, something. So in between, we still cannot see more detailed information. For example, structure conformational change. So the overall objective of this study is try to study the processing effect on its structural, conformational, and bioactivity about soybean lectin. So the major research design and methodology actually involve two labs. The very, very important person is Dr. Sate. So unfortunately, he passed away in 2019. So basically, his lab developed a lot of stuff. For example, soybean lectin purification. We need pure soybean lectin. Although there's something available on the market, but we still want to make sure this is a bioactive lectin. Second, he used this purified soybean lectin to develop antibodies. So after that, we got the purified protein and then used the antibody he developed to study in vitro SBA characterization. So in his lab, basically this is something basic strategy how to purify this protein from soybean lectin, ammonium sulfate precipitation, ion exchange chromatography, and then size exclusion chromatography. After that, we use hybridoma technology to develop monoclonal antibody. So, and this is spent years, okay? So you can see this publication he published in 1992. Basically, that's the key reference he used. After that, so basically this is just show you, okay, we try to characterize SBA. So this is a purified protein. So processing, we involve three factors. So temperature effect, pH effect. The last one is we use surfactant, sodium dilysyl sulfate, SDS. Basically, this is also a food additive. So basically from here, we want to know, okay, after all these kind of treatments, oh, this is changed to monomer or still maintain tetramer or aggregates. And then we use antibody to verify the immunoreactivity and then try to verify, we use pulsite red blood cell, okay, to verify the hemagglutinin activity. So our major finding is here. So first thing, we check the purity of purified soybean lectin. So basically you can see we use non-reducing SDS page. SDS page the same, okay? That means this is only use SDS. That's surfactant, or we can say that's a detergent too. So, and then we use two-dimensional gel electrophoresis And then this is a Western. And then we try to compare with commercial product from Sigma Outreach. So basically, after all this kind of analysis, we identify according to SDS page. So our purity is slightly better than commercial one, about 78% pure. And then another thing is through this gel electrophoresis, especially two-dimensional, we identify 3 subunits, monomer. So you can see that PI is so close. And then we verify that's use a Western blot. So we further separate these 3 subunits. So based on the molecular weight, so this is alpha, this is gamma, this is beta subunit. But so far, since that means, okay, the tetramer actually, that's a combination between these subunits. Which one is which? We still don't know. So related to pH involved, we call pH stressed SBA to study thermostability. So basically you can see here, this is a room temperature, acidic pH, neutral pH, alkaline pH. So the take-home message, you can see alkaline pH, acidic pH, hydrolyzed, small peptide. So that means cut into pieces. So basically we can say, oh, this soybean lectin is not that stable at acidic pH, but quite stable at neutral or above pH, alkaline pH. We also studied thermostability through studied aggregation temperature. So you can see acidic pH is not on body temperature, start to aggregate. And then neutral pH, alkaline pH, much higher. But we use a non-reducing SDF, we still can see this monomer, all monomer from room temperature and 70 degrees Celsius. This study is very, very important. So we use dot block to study thermostability of pH stressed SBA. So the first thing is you can see this is, we use one antibody Professor Sate developed, 585. Wow. Regardless the pH. So this antibody can detect all, regardless the pH, regardless the temperature. So this antibody can detect all dots. This is dots. So very, very important. So that means this antibody specific to a linear epitope. Epitope, that is the antibody binding site on target analyte. So that's a linear. That means, okay, so that means primary structure of that protein. Related to another very interesting antibody, 5G12. Okay, so you can see when the pH increase, oh, up and down, yes, no, yes, no. And then another thing is related for the same pH, oh, only can detect room temperature slightly. So basically you can see this is a conformational epitope antibody. So that means only quaternary structure can be identified. Wow, that's very, very useful antibody. I never seen one antibody really can only detect quaternary structure. Then if this antibody we can use to identify bioactivity. So combine everything together. So basically, we can see here pH 8.5, superior, better than neutral pH, better than alkaline pH, 9.6, better than acidic pH. So from now on, all the studies, we only use pH 8.5 to study. Okay, so related to temperature structural conformation of soybean lectin, we use a called Blue Native page. Blue Native as is. So that means when we dissolve this protein at 8.5 pH, we just load to the gel. So you can see here, first time we can see, okay, the purified protein actually maintain at room temperature, maintain 122 kilodalton. And then as the heating temperature increase, okay, I always thought this, we generate a lot of monomers. Nope, basically aggregates. So you can see this band shift to 70s, even 80s. So at room 80s degrees Celsius, tetramer disappear. So related to non-reducing SDS page here. All these kind of, no matter this is a polymer here, no matter this is a tetramer, they all change to monomer beautifully. So you can see this is SDS, that's the function, because this is a surfactant. They can destroy secondary structure and only maintain this primary structure.
Dr. Yao, I have, sorry to bore you. I have to remind you just 1 minute left for the speech. Sorry.
Oh, sorry. Thank you. Okay, I don't know, time goes so fast. Okay, so and then we transfer this one to Western blot. You can see this is 5G12. Okay, this is a conformational epitope. Then another one we transfer to, we use linear antibody to check. And then this is the last one. We can verify, use hemaggglutinating activity to verify. Basically, when the temperature increase, 70s, 80s did not show any HA activity. 60 degrees Celsius decrease half of HA activity. So our major conclusion is here. So basically, the take home, the major thing I already mentioned, the most important thing related to this study, and then for future usage, this antibody can verify therapeutic properties. Why? Because soybean lectin has been used for cancer therapy. So this is the beneficial property from lectin. So this is the thing, very, very important here. So all the others we have mentioned. So finally, I need to acknowledge Satay Lab, my lab students. Okay. Lastly, I want to thank the organizers that invite me to give this oral presentation. And then thank you for listening. So if you have any questions, feel free to ask me or email me. Thank you.
Hi, Dr. Fang, I think you are mute. still we couldn't hear you while Dr. Fang figure out connection. And thank you, Dr. Rao. It's a great pleasure to invite you to this talk. And it's really, really amazing. Great to know all this finding conformational epitope and linear epitope. Dr. Fang, can you lead the questions? Well, I think Dr. Fang's still working out.
Recording stopped.
There's some
Recording in progress.
Some connection issue. I'll start with one question that from the chat.
Okay.
I think people are very interesting to this SBA, especially in the soybean. There's one question mentioned of Monsanto. 孟山都公司的基因改造种子每年都要买它，对农业和食用它的大豆对人有害处吗？ I think this is sort of like related to what you're finding, but would you mind give your comments or thought about this, Dr. Rao?
Okay, so basically I think this is not really related to this topic, but this is GMO food. Right, so everybody has their own opinions. So I don't think I can give you more comments. But related to United States, basically everybody eating. But in China, maybe no. In EU, European country, the regulation is extremely strict. So basically, depends. But really related to the next one, 煮黄豆有 SBA, that's a good question. Basically, soaking, okay, fermentation, and then spouting. That these kind of processing will help to reduce soybean lectin. The key is for this presentation, I'm not trying to, because we eat soybean, I should say maybe more than 5,000 years, because China is the first country to develop soy sauce. So basically, we are so proud of this. But basically, to be honest, related to food, this is not a big issue at all. But related to animal feed, yes, maybe, because they're uncooked soybean everywhere. So even we call the byproduct from soybean oil manufacturer, we call the 豆粕 for animal feed, maybe also, undercooked. So this is good related to animal feed. Agriculture, that could be a problem. More interest is related to therapeutical usage, because lectin now has a lot of usage, not only from soybean or other legumes used for anti-cancer property. So these antibodies can help to identify bioactivity.
Great, thank you, Dr. Rao. Dr. Fang.
All right, can you hear me?
Yes.
Okay, sorry, I'm mute my self. All right. Okay, thanks, Dr. Yao, for the interesting and great talk. Shows the in vitro characteristics and the spatial soybean protein. Okay. Thank you. Due to the time limitation, let us welcome our next speaker, Professor Taiming Chen, to present his research on the hypothetical target ester sensors nanosystem with pH responser to alleviate alcohol liver injury. Professor Taiming Chen is a food nutritionist in China and selected as the world most influential scientist in food science. As a professor at the Dalian Polytechnic University, He leads the Dean of the Academical for the Interdisciplinary Science of Dalian Political University. Professor Tan holds 15 patents and he has published over 200 SCCI indexed scientific paper. So please welcome Professor Tan.
Good morning, good evening, everyone. Professor, thanks a lot for the kind introduction from Professor Fang. So it's my great pleasure to have this opportunity to give a talk in the first NACAN Summit Frontiers in Nutrition. So my name is Mingqian Tan. I'm from Dalian Polytechnic University. So today, I would like to give a topic about hepatic targeted acidic nanosystem with sodium iodide assistant pH response to alleviate alcoholic liver injury. So this is the outline of my presentation. There are 4 sections. So first, I would like to give a brief introduction of my research background. So as we know that everyone likes to drink alcohol during the banquet or some friends meet each other. So we know that alcoholic liver disease is one of the common liver diseases worldwide. So this kind of disease range from steatosis to more so alcoholic hepatitis, cirrhosis, and liver cancer. So there are lots of papers published about the mechanism as well as their diverse side effects of the alcoholic liver disease. So during the publications, we found that the mitochondrial dysfunction and the subsequent oxidation stress are identified as key factors in alcoholic liver disease. So our idea, because our seafood research center is merely studies some compounds from the seafood. So among them, basically, astaxanthin is a fat-soluble cationic, and with a molecular formula is carbon 40 and hydrogen 52 and oxygen 4. So astaxanthin can be found in aioli and yeast and salmon. So because there are lots of hydroxy and ketone groups and double bonds within the astaxanthin molecular structure, so it can enhance the ability to scavenge free radicals. So astaxanthin has been considered as one of the strongest antioxidants in the natural world. So because the above mentioned reasons, astaxanthin has been used in most of functional foods, cosmetics, medicine, and other fields. However, there's some limitations during the using of the astaxanthin because it has poor stability, lower bioavailability, poor absorption, as well as the lack of targeting. So our idea would like to improve the bioavailability of the astaxanthin to solve the problem of the poor water solubility as well as the poor absorption during our recent study. So during our study, we found that the liver-targeted delivery system might be a very useful strategy to overcome these limitations. So because the targeting delivery systems can prolong the blood circulation time of the astaxanthin and other biocompounds, so which can be specifically delivered the biocompounds to the targeting tissues. So during our study, we found that a receptor called acyl glycoprotein, APR, is overexpressed in the liver tissue, and which can provide advantage for the design for the liver targeted delivery system. So APR can recognize a variety of ligands containing glycose or inactive glycosylation residues in the liver tissue or cells. So from this background, the purpose of our study is to design a liver-targeted delivery system for the astaxanthin. So we want to use the delivery system to achieve liver targeting delivery to alleviate the damage of alcoholic liver disease. The second part, so I would like to introduce about the design and preparation of the liver targeted delivery system for astaxanthin. Sorry. Sorry, I would like to get this here. How to? So this one, in this section, in this part. So we designed the liver targeted system by using the lactobionic acid conjugated on the hydroxypropylsaccharodiextrin. So we use this very simple complex after the self-assembly in the water with the astaxanthin, they can form the nanoparticles. By using this method, we achieve the in vitro accumulation of the astaxanthin within the liver cells. So we then do the characterization of the delivery systems. We do the NMR and the FTIR, and interestingly, we found that the delivery system is spherical with a size about 150 nanometers. So by varying the different ratios of the starting raw materials, we can obtain different sizes of the nanoparticles. So firstly, we evaluated the free radical switching ability of the prepared delivery system. So from the left of this slide, we can, from the fluorescent images, we can see that the liver targeted delivery system can strongly decrease the damage from the hydroxy oxide. So from the right part, we can see this kind of delivery system can transport the astaxanthin to the liver. So for 4 hours and 12 hours, so for the targeted delivery system shows stronger fluorescence than the non-targeted delivery system. So then we studied accumulation of the delivery system to the HepRG cells. So similarly, we found very interesting results that the liver-targeted delivery system obtained more communication to the HepRG cells. So in addition, so we found that the liver system with astaxanthin can strongly can strongly protect the mitochondrial membrane potential. So however, the above mentioned, the second part only through the in vitro evaluation, we know that if for the oral administration, so it can be damaged during the strong acidic environment during the stomach. So then we design and preparation of a new kind of delivery system with a strong pH response to further protect the acetylcysteine in the stomach. So we just simply introduced sodium iodinate. We used the SA coating on the nanoparticles we prepared in the section 2. Then we found that these SA coating nanoparticles can resist the damage of the strong acid in the stomach. So by using this strategy, we can do the in vivo application of the nanoparticles in the liver, in the alcoholic liver disease in mice model. So we did a lot of characterization of these nanoparticles, similar as before. So we also do the cellular evaluation with the prepared liver-targeted nanoparticles. We can find that after the SA coating, the liver-targeted nanoparticles can still accumulated within the HepRG cells, which has the APR, but for HUVC cells that without APR, the nanoparticles cannot bind with them. So we further evaluated the biodistribution of these nanoparticles in liver. So we found that after the liver SA coating, the liver-targeted delivery system can bond with the liver tissue than the non-targeted one. You can see this image. So very stronger red fluorescence can be found during 4, 5, and 24 hours. That means our strategy by using SA coating liver-targeted nanoparticles can specifically recognize or accumulate astaxanthin within the liver. So we also check the antioxidant ability of the liver system. We found that for the oxidant hydroxy damaged nanoparticles, the cells, so the liver system can well protected from the damage. Also, the mitochondrial membrane potential will be increased after treatment with the SA coating liver targeted delivery system. So then we test the safety. That means the cytotoxicity about the hepatic targeted astaxanthin delivery system. So before the in vivo application, this is very important. So from our data, we found that it is very safe among the testing dosage from below to 50 microgram per milliliter. So then the section 4, we do the in vivo evaluation of the hepatic targeted acid-sizing nanodelivery system with pH response. So firstly, so after the evaluation in mice model, so we do the HE staining. So we can, from this staining, we can see that after the alcohol treatment of the mice, there is a lot of fat droplets caused by alcohol. This is white droplets that is fat. So this is a healthy mice. So we can see for the targeted delivery system treatment group, so the liver tissue is very similar as the healthy one. But for the free exercising as well as other control group, they are not good as the liver targeted delivery system. So we also checked the other main organs during the mice model. So we didn't find very significant difference among the small intestine, heart, spleen, kidney, and lung. So we then tested all the other factors. So we found that the delivery system can reduce the alcoholic-induced ALT and AST, as well as the TNOS, INOS, as well as MDA in mice. All the data show that the liver-targeted delivery system is effective in the elevation of the liver alcoholic damage. So we further tested the microbiota. So we found that we collected the fecal samples from the testing groups. So all the results indicated that our delivery system exhibit better bacterial species uniformity and richness than the other groups. So we then evaluated the different intestinal microbiota in mice. So compared with the model group, the liver-targeted group could significantly restore the abundance of beneficial bacteria. And the liver-targeted system can reduce the abundance of free inflammatory responsive agenda, that's Phylobacterium. So we also tested the heat map. So we found that the liver-targeted delivery system can dramatically increase the good microbiota abundance and decrease the bad microbiota abundance. So all of the results indicate that the pH in response liver-targeted delivery system is effective for exercising delivery during the protection of the liver alcoholic damage. So I would like to give a brief summary. So in this study, so we designed and prepared a self-assembly nanoparticles to improve their stability and the solubility of exercising. So this liver delivery systems show a pH-triggered response because we use the sodium adrenate as a raw materials for surface coating. So the lactobalic acid was used as a liver-targeted molecule, molecular for the hepatotoxic accumulation. So the hepatic targeted astaxanthin nanosystem elevated alcoholic liver injury in mice. So that's all my introduction during this study. So finally, I would like to thank my group members as well as Professor Baby Zhu. And I would like to thank the funding from National Nature Science and the Foundation of China and the Ministry of Science and Technology. So I would like to you all the scholars to give some feedback about my research, and thank you. That's all.
Okay, thank you. Thanks, Professor Tan. It is good to know how the nanosystem works for deal with the alkaline liver injuries. This research will definitely help out the people who love drinks. Is any question for the Professor Tan? You can type the question in our chat room. I will check the chat box. Okay. The one question is, what is the usage for this research? And how do we use the research result in daily life or impact on lifestyle?
So basically, we did this study. We would like to design and create a new kind of functional food, like some drink with the astaxanthin to elevate the alcohol damage. Because we have lots of meetings, we have we drink lots of alcohol or baijiu, so it's very harmful to our liver. So before drinking baijiu, then we drink a kind of the functional drinkings like astaxanthin. So it might be helpful to protect your liver. That's the purpose.
Okay, one more question. Can you explain why lactobiotic acid would target liver tissue?
Oh,
in the chat
actually, this is a very good question. So the LA can bind to the APR. So that's a very specific binding. So found several years before. You know, this is because the structure, this carbo compounds can bond specifically, like a click chemistry. So we just use this point to design the liver targeted liver system. So that's not our fund, but we use this phenomena to design. So I would like our colleagues to use this and to prove this. I think this is very useful. That's all. Thanks. Professor Fang, we cannot hear you.
I think we got another question while Dr. Fang is trying to reconnect. In the slides, it mentioned the low bioavailability and the low absorption of the astaxanthin, and the study was bioavailability was conducted in the HEPG2 cell. Is it enough to tell that the emulsion and encapsulation technology here enhanced the bioavailability for animal or humans?
Right. We just do the in vitro and in vivo evaluation of the liver targeted liver system. So probably because you know this kind of LA, so it's very biocompatible. We hope that in the future we can use this liver targeted liver system to design some useful drinkings for the human. We just use some medicine delivery system idea to design for the delivery of for the nutrition. We would like to introduce some biocompounds from seafood. Then we use the delivery system to enhance their bioaccessibility and to further decrease the cell side and the side effects from the medicine, because we everyone won't like to eat the medicine, because if we eat some exercising, but it may be helpful for our health. That's all the purpose of our study.
For your clear answer. If you guys have more questions, please to contact Tan's email. For the next presentation, we're going to explore the development of dynamical in vitro gastronomy model to study the behavior of food, non-food materials in human digestive system. All right. Dr. Kongfang Bing is a professor in the Department of Food Science and Technology at University of Georgia. His current research includes design human gastrointestinal model, study design the digest of food and non-food materials, and developing novel food pasteurization technology. Dr. Kong has published 83 papers in peer-reviewed scientific journal. All right, please welcome our speech, Dr. Kongfang Bing.
Thank you, Dr. Fang, for your kind introduction. Can you hear me?
Yeah, go ahead.
Okay. Good evening and good morning, everyone. My name is Kongfang Bing. I'm a professor in the Department of Food Science and Technology at the University of Georgia. My presentation is about the development of dynamic in vitro GI models. This is the outline. I will give a brief review of the human GI system, and then I compared a brief introduction of static model and dynamic model. What are the different features, and some introduction about the design and function of dynamic model and application and some of the findings. And at the end, I will present some of the future direction that in my mind. Human digestive system, as we all know, it has major components, including mouth, stomach, small intestine, and colon. In this different area, these different organs, they have different functions. In the mouth, it's mainly the food is chewed and mixed with saliva. And in the saliva, it contains amylase to digest the starch. The pH in the saliva is about neutral, and the food, the chewing time is about between 10 seconds to 2 minutes. And after chewing, the food break down into pieces and form into a round paste-like material that is called bolus. So bolus go through esophagus and reach in stomach. In the stomach, there are mechanical processing and enzymatic processing to further break down food. Mechanical processing is from the peristalsis. We all know that the contraction in the stomach, peristalsis, that apply a mechanical force that is critical to break down the food. And enzymatic processing from pepsin and from lipase that work to digest proteins and lipids. So the pH in the stomach is in a wide range from 1 to 5, depending on whether or not the food is ingested. And the residence time in the stomach from 15 minutes to 3 hours, depending on what type of food or drink. So it has big difference. So in the small intestine, there's segregation of a pancreatic juice that contains enzymes to further break down proteins and carbohydrates, and also bile acids. The residence time is about 2 to 5 hours, and the pH is about neutral. And then this undigested material, mainly fiber, go to colon. In that, fermentation takes place to break down some of the fiber and form short chain fatty acids, which are critical for human health as well as for the microbiota. In colon, this food can stay for another half day to 1 day before they're emptied from the body. So in order to understand how food is digested, how nutrients are released, as well as the bioavailability, it's very important to either use a human study or animal study to look at the details. But this, although we call this is a golden standard, that is very time-consuming and also expensive. In order to do animal study or human clinical trials, we have to get a lot of paperwork. I think everyone knows that take a long time to get the approval, IRB approval. And also that's very expensive process. So in vitro models is commonly used. So in vitro model, including both static model and dynamic model, that's what I'm going to talk about today. They have an advantage of a low cost, it's fast, it has a better repeatability, and it's easy to operate. And also it has no ethical constraints. So that makes this is a very good substitute methods. In the past, I would say actually now the static digestion model is more commonly used. So the static model, that is a simplified model. In this model is conditions, it's a physiological conditions. It's maintain constant, that including constant pH, constant enzyme concentration, and constant volume. For example, on this diagram, it is showing a 3-phase digestion trial that including oral phase, gastric phase, and small and intestinal phase. We can see that actually it has 3 containers. In each container, you have simulated saliva, simulated gastric juice, and simulated intestinal juice. And you actually add food into the saliva and mix for some time, and then you add gastric juice and mix for another 2 hours, and then you add intestinal juice, mix for another 2 hours, and then you take samples from each phase and measure how the concentration changes. So that tells us the information of the nutrient release and the digestion kinetics of this some of the nutrients and bioactive compounds. So mostly this kind of static model, the mixing part is by using either a shaken bath or using stir bar or using a like this is a USP. This USP aerators, they actually use a blade mixer to mix the contents. So as you can see, this static model is oversimplified because in the human GI system, many of the parameters actually is not constant. And also the mixing is not like this. So this slide's just a brief introduction of stomach. So in the stomach, we can see how this food is digested and what are the major movement of the stomach take place. So this video, we can see the food reach the stomach from the fundus and the body. This means to function as a reservoir for store food. And then in the antrum, this lower part, that has a strong contraction and that apply a mechanical force to break down foods. So this video showing how this peristalsis take place. And we can see this contraction start from the top and gradually move down along the stomach to the antrum, which is the lowest part of the stomach. And then these small particles, which has been reduced size into 1 to 2 millimeters, can go through the pylorus. The pylorus is a valve that only allows small particles to go through to reach intestine. And these large particles will be rejected back to the body. And so to repeat this breakdown process. So this video is a endoscopy film that shows clearly what happens inside the human stomach, inside the antrum. And we can see how this contracting rings, trap the contents into a small space, and that causes a grinding effect that reduces particle size. And this diagram just showing this process. Firstly, there's a propulsion in which your contraction waves push the particles into a small space, and inside of this small space, there's particles grinding against each other, and that's caused friction and size reduction. Again, these small particles go through the pylorus to reach intestine, and large particles just retain in the stomach body and continue repeat the process. So this is called retropulsion. So in order to fully understand how food is digested, we need to simulate this kind of process, the peristalsis. And in the past, people have done study in vivo testing to look at how much mechanical force created by this kind of peristalsis. So this kind of results provide a very good reference for simulation. And also, it's important to know that the pH in the stomach is not constant. As you can see, in the fasting period, the pH is about 1 to 2. But once you eat food, the pH rapidly increases because the buffer effect of the food to reach up to 5 to 6. And then with the digestion continuum and the separation of the acid and also the reduction of the volume, the pH will gradually return back to the about 2. So this different pH, this dramatic change of pH has a big impact on the enzymatic activities because enzymes, they have this optimal pH. And another important feature is about gastric emptying. As you can see, the solids are emptied. It's following a sigmoidal curve, while liquid is following a exponential curve. So these different mechanisms also are important that affect the digestion of solid and liquid foods. So all these are very important in this affecting food digestion and behavior of the food material and nutrient release, and as well as bioaccessibility and bioavailability. And these are the things we want to take into account when we design a dynamic model. And if we look at the small intestine are different. The pH is mostly about 6 to 7, and the contraction of small intestine is different with the stomach. Stomach is mainly peristalsis, but small intestine, it has 2 different types of motor patterns. One is peristalsis, that's the same as stomach that can move material to move along the intestinal tube. So another one is a segmentation, and segmentation is actually a localized contraction. That means the contraction ring is not moving; it just stay on that location. So segmentation mainly function to mix the contents so that the mixing itself can enhance the mass transfer and promote enzymatic hydrolysis. So with that, we see dynamic GI model is nothing. It's trying to incorporate all these dynamic changes in the pH, the movement, the enzyme, and emptying, transition, trying to include all this into the model. So that we call it a dynamic GI model as compared to a static model, which is mainly focus on this predetermined constant parameters. So far, there are some commercialized models available in the market. And on the left, it's called the TIM model, which is a very famous model that was developed in Netherlands. So this model, as we can see inside, they have these tubes actually collect each other in series. So the top one is stomach, and then this lower part, these are 3 sections of intestine. And so how do they simulate peristalsis? Because we see contraction is one of the most important features of the GI system that apply mechanical force that is critical for food digestion. So what they do is they actually they use this ejected layer on the tube in the tube wall. So there's a ejected layer inside. They use pressurized water. The water is pressurized and depressurized, so that it can cause a change in pressure that causes a contraction effect. Okay? Again, this is a very famous model. It has been used in many areas of nutrition studies and pharmaceutical industry. It's a very expensive model, actually. So I'm not sure if we can buy that in China, but in US, I know that some universities they have this. So it's because it's very expensive. It's not very common. It's not very easy to buy it. And the one on the left is another model to simulate only for stomach. This is from UK. It's called a dynamic gastric model, and we see this. It has the top to simulate the fundus, the main body of the stomach, and the antrum, which has the main contraction take place. They are simulated by 2 cylinders. It's outer cylinder and the inner cylinder. So this inner cylinder can move in up and down. So that and on the top of the outer cylinder, there's a small hole. It's orifice. So when the inner cylinder moves back and down, it pushes the fluid to go back and forth through the orifice. So that causes a shear force. That is to simulate what happens in the stomach, the antrum contraction. So these are the 2 commercialized models in the stomach, in the market. So as we can see, even these are available, but these are very expensive, and also is for some it can be used for some research, but may not be really suitable for all kinds of research. So for different purpose, we want to develop our own model. That's what we have done in the past years. So next, I'm going to give a brief introduction of some of the models that I have been involved. One is a model stomach system. So this one, as you can see, it's just a motor. It's a motor in rotation, and inside we have a inner chamber. Inside the inner chamber, this has a simulated gastric juice, and we have this plastic beads, which is free moving with a density close to water. So, and then you put food samples into the 4 sample holder. And then when this is rotation, so these beads give a force to the food samples. So that's to simulate a contraction force, because we can adjust the rotation speed, so we can adjust this shear force, and also we have this force sensor can measure the force simultaneously. So for that, it's good to look at the food breakdown kinetics. So with this model, we have found some interesting kinetic information about the food breakdown. We call disintegration of solid food. For ham, raw carrots and roasted almonds, we can see they have a different profile. And on y-axis is a fraction remaining, and then the x-axis is time. As you can see, there's an exponential decrease for ham. There's a sigmoid difference for raw carrots, and there's a delayed sigmoidal decrease for roasted almonds. Delayed sigmoidal means there's a lag phase in the initial stage. So that we found this is very much in good correlation with the emptying profile, the solids and the liquids. You can see the raw carrots, these almonds are more close to solid emptying, or ham is more close to liquid. So that's an indication that the breakdown process has a good relationship with emptying. And we developed mathematical models to model this different profile. And also we have done some study to look at the mechanisms. So we found the surface erosion and the absorption of gastric juice and texture softening that has been worked together to cause the different performance of these different food products. Later on, actually one of our colleagues, Professor Gail Bonhorst, they categorized food into different categories, and based on this texture softening process of each in the gastric juice, which is very interesting. So another model that we have, I have been involved, that was done at UC Davis, and we have developed a human gastric simulator. So this one is looking more like a stomach. So what do? We have these runners and a belt these runners move from the top to the bottom to compress the stomach chamber. So inside to form a contraction ring, and that contraction, we try to simulate this propulsion, grinding, and this retropulsion process. So this is the rice. We can see it looks pretty similar to the interim contraction process. So this we can see for rice, after if we use a shaken bath, a static model to digest rice, we can see it doesn't matter how long you put the rice into the gastric juice. In the static model, they never break down the particles. But in the HGS, they actually can form a very nice paste, because this very efficient breakdown process has taken place. So that actually makes this look very similar to what we observed in pig stomach after rice digestion. And we compare the force that's generated between HGS and these human clinical trials. We can see the forces, the frequency, the pulses, the frequency, and the value of the force are pretty similar. And also, if you look at the pH, which is another important aspect that I want to simulate, and this is the pH changes in the HGS, and this is in the stomach. Okay, so I think I have only 5 minutes to try to try to speak faster. So again, this has a pretty good, pretty similar. These pH changes. And recently, we developed another model that's called DGSM, and this one is mainly to use a texture analyzer to bring a probe. Okay. So let me go back to the previous slides. Okay, so just to show you how this is done, this contraction is simulated by this movement of the probe to compress the food. Okay. So we use this actually to help a company look at their commercial enzyme supplements, and we found the digestion. We look at the emptied the fluid from the stomach, as well as compare that with a human study, and we found pretty good similar trend. That means in the beginning, there's a very low concentration of the digestion of the lipid digestion, and then it reached a peak. After that, it gradually decreased, and actually in the in vivo study, it shows a similar trends. So that's again confirmed this dynamic model. It has a good simulation of this real effect of lipid digestion. We use that to look at the viscosity effect on gastric emptying, And also we use the data to predict, to develop models to predict the gastric emptying of solids. These are, some interesting results. And we also develop a advanced gastric model. In that model, we use this pneumatic syringes to compress a J-shaped stomach. So this is the model that we have in the lab. We have this, it's the model, and this is the control system. I can just go quickly so that I can show you more slides. This is the stomach that we made using silicone, and these are the tubes that's responsible for segregation of enzymes and acids. And this video showing how this repulsion takes place. You can see the repulsion actually takes place in the model. And we have done this intelligent model too. This is for a duodenum model. In that model, we use this again pneumatic. So we use this pneumatic, this air pressure to create a contraction. Just to simulate the segmentation. It's a very important pattern. Okay. So this is how the model is operated. Okay. Recently, we have developed a SIS, another model, because we have different types of models. So that's the reason is because these different models, they can have different application, and they can provide the different information. So we use this model. This is called a small intestinal simulator. We use this model to look at the intestinal transit of food, and also look at the residence time. We look at how the viscosity and also segmentation affect the residence time, the traveling distance, as well as the word contact frequency. The word contact frequency is actually an indicator of the possibility of these nutrients being absorbed. So we found some interesting data. So we can, if you have interest, we can communicate maybe after the meeting. So we also apply a pig intestine directly fit to our model, and so use that to make this an ex vivo model. And we use this to look at the effective intestinal permeability, and we got pretty good results using the ex vivo model, and also compare with dialysis membranes. So just last year, we have done a study to compare static model and a dynamic model, look at the effect of cinnamon on starch digestion. In that, we use Rasputin as a food model food. And so the static model, again, we have these three phases. And dynamic model, we have oral phase, and also we use our model, the stomach model and also intestinal model. We combine this together to look at what's the difference of the starch hydrolysis as affected by cinnamon. So we found interesting results. As you can see, we found using dynamic model, there's a higher starch hydrolysis as compared to static model. And also in the dynamic model can show clearly this cinnamon, it has a significant impact on the starch hydrolysis. That means with cinnamon, the starch hydrolysis was reduced. But this is not shown in the static model. So static model, they cannot show significant difference, as you can see here. So why this happens? This is because, again, the pH, the different pH pattern, and also the continuous segregation of enzymes, and also the contraction that break down the particle size, all these contribute to this difference. So from that, we can say dynamic model really is useful to give us detailed information. Just a brief conclusion, we found the dynamic model is really useful, and also they can be designed in different ways for different purpose. So dynamic model and the static model, they can combine to provide more convenience in the research and information. So in the future, we are looking at probably maybe standardized design, because now many universities, many labs, they develop their own model, but it's very difficult to compare against among these models. So a standard guidelines such as the criteria for geometry, for this motility design, this will be helpful. And also the simulation can be improved with the advancement in the technology. So these are my lab, and thank you very much for your attention. That's all.
Thank you, Dr. Kong. Very informative. And I think everyone here is being amazed by how many models that you have mentioned in this study. And it's really great work. And while we're gonna share more questions and answers, please leave your questions in the chat box. And Dr. Kong, I think you have mentioned more than 7 models in your presentation. I didn't, I took some notes. I'll propose one question first is, what would be the food format or food component that will impact, or how you choose your model when we were using the model to evaluate digestibility or absorptibility for the different food formats, such as liquid food or solid food or semi-solid food? And also, how about for different food components, such as high fat or starch-rich food?
That's a very good question. That's why I mentioned that there are a lot of different models. Probably people will ask why you should have this many different models. I would say each model has their unique advantage in terms of certain application. So, for example, if we want to look at the digestion of solid foods, then we must know that this contraction force, the mechanical force, this is critical. This is really important to make the digestion more effective. So in that, we should consider, if we want to select a model or want to design a model, want to make sure that this model is able to provide enough contraction that a similar level of the mechanical force. Otherwise, your digestion probably is relatively limited as compared to what happens in the human stomach, inside the human body, and also similarly for the intestine. I think we noticed there are several different intestines that we have made. So why we want to do that? Because some of the intestine just straight tube, and some intestine model are not straight. They actually have this up and down, this sigmoidal shape. So that's because we want, for this sigmoidal shape, because we want to look at how these particles going to, so let's say if you have particles go to small intestine, and how these particles is going to affect their residence time, their movement around the tube, because there's gravity impact. Gravity, in fact, you should consider that will affect their movement. So I think Dr. Xu's question is, I would say if we needed to look at case by case, what kind of food material and what is the purpose of your model study.
Thank you, Dr. Kong. And also we have another question regards to proposed by Hempong. Some material used for digestion study or oxygen sensitive. What is the composition of the air in the stomach and intestine according to your best knowledge? And is there any control of the air in your model?
That is doable because most of the model is actually most of the model they put in an insulated system. So inside you can certainly flush with nitrogen to remove oxygen. I think from the technical perspective, that's not very difficult to realize in the model.
Got it. Yeah, thank you, Dr. Kong. In terms of timing, I have to skip to for the more questions. And if you have more questions, the audience, please leave a message and or email Dr. Kong. And I see some people who would like to know more opportunity in your lab for collaborations for sure. Please feel free to reach out to Dr. Kong for through email. Thank you, Dr. Kong, for the fantastic talk. And for the next, thank you. For the next, I'm gonna start introduce our guest speaker of Dr. Zhao Junwei. Professor Zhao Junwei is the distinguished professor at the HFUT and the Dean of the School of Biological Science and Engineering, now Minzu University. He also served as the chairman of the Agriculture and Forestry Specialty Food Processing Industry Technological Innovation Strategic Alliance of Anhui Province and the Hefei Society for Nutrition. Dr. Wei's research focused on the processing and the function of nutraceuticals from the byproducts of agriculture and forestry, such as gingerols from ginger, moringa, and DNG from mulberry, and others. Thank you. Please join me to welcome Dr. Wei, and the floor is yours.
谢谢啊，我就用中文讲了啊，谢谢啊，非常感谢介绍。我今天的报告呢是黄金的功能成分，就是在食品当中的利用。从4个方面开始介绍。首先呢，黄金，因为黄金这个呢，实际上呢，整个世界呢，目前有70余种。它主要呢，但是在国内目前有41种，37种呢已经得到确认。我们目前在中国的话呢，主要用的黄金是四种，制豆黄金、多花黄金和碘黄金。这个呢，实际上是常用的，我们称为叫黄金。然后呢，玉竹的话呢，它实际上也是黄金的一种，从分类学来讲。但是的话呢，它我们称为玉竹，但是在这个没有入了中国的药典，是这样的。第二呢，我们讲黄金的化学成分。目前来讲，黄金的成分主要呢，我们研究的是多糖，还有皂苷、黄糖和类黄糖，还有磷基素这个方面。当然了，它其他方面例如挥发性油啊，还有一些其他的生物碱也有这个报道。在整个来讲，目前研究比较多的呢是枝头黄金、多花黄金呢和碘黄金还研究比较少。目前还总提取物呢研究比较多，单一的化合物呢研究比较少。同时的话，目前多糖啊、皂苷啊、磷基素呢研究呢逐渐是增多，研究的热点可能是我们就是构效的关系。黄金的成分，目前我们3种常见，在国内的话常见的黄金当中呢，我们主要实际上呢是有85种这个活性物质呢被鉴定出来。首先我们讲讲多糖，多糖的话呢是我们认为它是一个主要的成分，同时的话它果糖是黄金当中的一个最多的含量最多的一个单糖。同时的话呢，我们目前可能比较注重的是实际上是一个构效关系。目前在黄金的多糖当中，因为我们都知道多糖实际上是非常复杂的，你想研究还是很难。同时多糖的含量呢，它受不同品种、不同的加工方式，还有呢野生型和培养型，还有种植的年限呢，实际上都是有一定的是有一定很大的差距。然后皂苷的话，目前是鉴定的呢，自身为的鉴定有80余种。80余种的话，从我们枝头黄金，我们实验室研究的主要是我们安徽的酒花黄金。酒花黄金呢，它是俗名，真正称谓呢，它实际上是一个枝头黄金，20余种皂苷这种另外一种呢，我们在黄金当中引用比较多的呢，实际上是一种蛋白，是磷基素，它实际上是一种这个非免疫性的结合蛋白，它与功能与癌症的病理等等有关。我们实验室研究的是比较多的是皂苷，它的化学成分从提取，实际上提取的目前提取纯化，它是也是一种常规的。例如讲我们多糖热水 这水提纯成，这实际上还是我们多糖的一个常用的方式。例如黄酮、类黄酮的实际上还是一个纯提，目前的就是这种提取的方法。在这地方我列出来了这个例如讲多糖的提取，它主要还是热水提取，热水提取之后然后用纯成。那个纯化的话呢，主要是DA 柱啊，还有一些柱子进行一个这个方面的在黄酮的话呢，它实际上还是一种那个纯成，同时目前报道的话呢，它有一个超声辅助提取，那个例如像蛋白它实际上就是酸提这是一个常规的方法，然后你利用我们一定柱子根据分子量大小把蛋白提取出来。例如多酚类的实际上你用石油醚提的话呢还是非常多的，例如这个异物醇啊等等，这个提的比较多。3点我们讲一下我们整个黄金的一个健康的功能，这是我们前期发表的那篇文章上面一个综述。我们总的呢，我们把黄金整个一个在食品上利用，我们分为5个阶段。第一个阶段就是这种野生型，第2个阶段的话呢是我们传统的中药呢我们作为第2阶段。第3个阶段的话呢，我们是把它的一些干燥，因为黄金的话，如果各位老师如果做过黄金的话，你也知道黄金的干燥是非常的困难，所以呢我们在第3个阶段可能是干燥和加工的方式实际上是一个非常这个。目前的话呢第4个阶段的话呢，我们认为我把它作为2000年以后作为一个成分的提取，还有一些功能的研究，还有我们目前的话呢，我们主要是增加这个活性物质功能。至于黄金整个利用的话呢，我把它例如讲那个抗衰老、神经保护、抗氧化，还有降血糖、抗炎、抗癌症，还有这个抗骨质疏松，还有抗疲劳等等。这个呢，我们主要是把列为这块。这个相互的关系的话呢，我们是做了一个表，如果各位老师感兴趣的话，可以看我们那篇综述的那个文章。这地方我列出来一些整个我们抗衰老抗癌的话呢，我们目前研究抗癌的呢，实际上呢一个多糖，一个皂苷，一个甲基化这个皂苷，这是我们实验室做的一些工作。那个比如讲在抗氧化呢，我们还是一种这个多糖啊，这研究的比较多。抗骨质疏松我们还是用多糖做研究的比较多，还有这个免疫活性呢，这个还是多糖啊，所以呢例如讲这个神经保护啊，抗糖尿病还是一些多糖，应该研究的多糖的呢是比较多一点。下面呢我还重点讲一下，介绍我们实验室的一些工作。我们实验室的话，目前可能在黄金上面也做了10几年的这个方面的工作，因为利用我们安徽的黄金提取首先呢我们提取这种皂苷，这种皂苷的话呢，这个结构是在这地方利用我们核磁进行一个鉴定。在这种呢，首先的话我们实际上是比较了不同的癌细胞，例如肝癌这个还有这个子宫内膜癌等等。这种呢我们利用肝癌细胞的话实际上它的 IC50 这种得到是8.34微摩尔，8.34微摩尔的话，我们利用这种呢，我们就进行了一个研究。例如这一部分我可能稍微讲详细一点，后面可能就讲简单。它实际上呢，它把我们整个细胞的周期组织在这个 GRM 期。可能如果各位老师如果做过这方面，你们就有经验。实际上不同的成分，那同样的成分对不同的癌细胞，它实际上是底蕴不同的。同时的话呢，我们把组织在这个周期，我们研究了相应的周期蛋白，这个周期蛋白和周期基因的表达呢，也印证了我们这个组织在 GRM 期。同时的话呢，它实际上是对于我们早凋的细胞呢，对凋亡的时候，诱导凋亡对早凋细胞影响比较大。同时它诱导这个ROS 的积累 ，ROS 积累的话，实际上就会促进我们整个肝癌细胞的凋亡。当然我们呢进一步看了利用利用我们这个心理体通过的抑制剂的话呢，我们明显看到的话呢，在加入这抑制剂之后，我们这些心理体通过相关的蛋白和基因表达量下降的非常明显。当然我们在 再加入我们这个那个皂苷之后，这个排量是明显上升。所以呢，我们认为是心理血通路是一个通路。在死亡受体通路当中呢，我们用死亡受体通路的这个抑制剂，我们也可以得出一个同样的一个结果。这个地方呢，我们在一些其他的一些通路当中呢，我们得出一个类似的例如讲那个凋亡的诱导凋亡，这篇文章我们发表在 Food Chemical Toxicology 上面。我们进一步呢，对甲基化这种皂苷呢，甲基化进行研究。甲基化皂苷的话呢，实际上我们比较了2种细胞，癌细胞，一种呢是这个肝癌细胞，一种是子宫宫颈癌细胞。在宫颈癌细胞当中呢，它是效果更加明显，就是叫 RC50 值是 18.31微摩尔。我们一般来讲，我们认为如果 RC50 值大于10以上的话呢，我们认为是作为功能食品比较合适。如果是在这个个位数的话呢，μ摩尔的话，我们认为是做药是比较合适。所以呢，进一步的话呢，进一步我们这个甲基化的这个皂苷的话呢，只是把细胞组织在 GRM7，所以这篇文章的话，我们也是在 Food Chemical Toxicology 上面。同时的我们进一步看一下，因为我们刚才讲了不同的同样成分对不同的这个癌症实际上是有个显著的变化。我们进一步看一下我们这个皂苷的话呢，对子宫内膜癌这个细胞的这个凋亡的影响。在我们比较了4种不同的这种4种不同的这个皂苷，我们这种皂苷的影响比较效果非常明显 ，RC50 值呢是在个位数2.37这个微摩尔。同时的话呢，对这个子宫内膜癌细胞的话呢，它这个诱导组织在周期的嘛，应用与亲密不同，它把组织在 G0和 G17，而我们亲密两种成分在这个肝癌和这个那2种细胞当中，我们是组织在 GRM7、GRM， 所以呢，这个我们就进一步就做这篇文章的话呢，可能因为如果感兴趣的话，可以看我们的文章，我们发表在这个在 Food Chemical Toxicology 上面。我们进一步看一下对这个对我们粘合质不同的组学，看看我们这个这种皂苷对整个的对细胞的增殖，你看处理完之后对细胞的增殖对细胞的这个倾斜就有显著的效果，就有显著的这个抑制作用。同时的话呢，我们利用小鼠的模型明显的看出来因为皂苷处理完之后，对子宫内膜癌这个小鼠的明显是有那个可以提高这个可以抑制癌症这样，就是癌症的这个肿瘤细胞，比如体征等等都有一些这个影响，对于这个从这个细胞的水平这个影响。进一步的话呢，我们看一下我们属于皂苷处理完之后，我们这个从 mRNA 水平的话呢，356个的话呢，我们这个 mRNA 显著上调，522个呢显著下调。从马克而言的话，31个马克而言呢是显著这个上升，64个呢马克而言的话呢是显著下降。同时我们把这个马克而言进行呢，就是显著差异变化的 mRNA 跟这个马克而言的话呢进行一个负极，进行负极分析完之后，我们看到这个主要差异表达的基因主要是负极在这个 IL-7这个通路、MIPK 通路、Lodge 通路，还有其他方面的一些通路。我们通过划痕呢跟 Tracewell 呢，我们看一下，我们这个属于皂苷的话呢，是可以呈这个浓度依赖式的，就可以抑制的话呢，我们癌细胞的这个倾斜还有这个迁移等等，我们这玩意是非常明显，可以非常的显著。然后呢，进一步的话呢，我们通过这种 Western blot 和这个去进行。在 Western blot 的时候呢，我们实际上呢，我们注意涉及到相关的通路，我们在下面的话呢，我们是进行一个对于我们这一些通路的 MIPK 等等这个通路是明显这个诱导这个蛋白的这个表达量增加。我们进一步，我们用这个用我们这个抑制剂，例如讲我们这个整个抑制剂这个是激活剂， 我们加入激活剂之后，加入这2种激活剂之后，实际上是可以显著的呢，可以显著的这个增强这个清洗这个能力，增强这个。但是呢，我们在激活剂和同时我们再加上去之后呢，加上我们的皂苷之后，可以抑制的话，我们这个清洗。同时的话，我们进一步我们围绕结合这个马奎尔胺和mRNA的这个组学呢，我们进行一个联合分析。我们看到呢，我们有24个这个 DM 和21个呢差异表达基因呢与 MPI 同有关。这篇文章呢正在那个处理中。同时的话呢，我们因为我们摄影师对这个在研究皂苷的同时，我们另外有学生呢也在做这个整个多糖这方面。在这多糖方面，因为我们知道现在多糖研究的比较多，我们多糖也发了几篇文章。多糖的话呢，我们实际上是采取这个凝血提取。例如讲呢，我们用酸提的话呢，我们第一步首先采取浓酸提取。浓酸提取进一步的话呢，我们这个把浓酸提取的残留物，我们进一步用这个就是这个低温的这种酸进行一个提。再进一步呢，用龙井进行提，对这个残渣进行龙井提取。龙井提取的话呢，再进一步用这个湿井提取，然后进一步呢用龙井提取。这样的话呢，我把它命名为这个凝血提取。对于这个凝血提取多糖进一步进行纯化，纯化你具有多糖的这个典型的分子量呢也明显的不一样。其中呢，我们是龙井最后一步的龙井呢是分子量是最小。对的，热稳定性的话呢也有显著的差别。在热稳定性还有我们流变性，这种流变性的话呢，实际上它表观凝度的话呢，它实际上我们是最后一个这种成分的话呢，是表观凝度是最强。然后我们对这个整个表观凝度，我们它成一个那个典型的非流动流体。然后呢，我们非流动流体。然后我们例如讲这个浓度啊，这个高温啊、低温，还有这个钙离子、钠离子等等，对我们表观凝度都有显著的影响。因为这地方我们考虑到这个时间，我这地方 PPT 我都没有放进来。我们对这个整个表观凝度的话呢，实际上它还是表现出来一个紧切湿化的一个在这个低振荡频率的时候呢，实际上是弹性的这个占主要的一个模式。在这个那个振荡频率比较高的情况下，实际上呢，它显示出来一个这个液体的这种粘性的这种性质啊。我们进一步做抗氧化性，我们看到抗氧化性的话呢，我们这个多糖，我们4种多糖的话呢，实际上在不同的抗氧化性指标的话呢，可能是抗氧化指标是有显著的差别。所以的话呢，我们所以经常我们要求学生在做研究的时候，我们是要求你做单个的指标上而不可选。例如讲，我们 DPPH 实际上是 CIS 的话呢，实际上也就是我们的溶解，就最后一步残留分子量最小的那个是 DPPH 的吧？DPPH 这个活性性成分最高，因为这个 DPPH。例如讲，我们在这个ABST 的话呢 ，ABST 呢，我们 DIS 呢，我们活性是最高。DIS 的话，实际上呢，它是湿碱容易提取。例如 DIS 的话，湿碱容易提取的话，我们这个铁离子啊，还有我们这个羟基自由基的话呢，它都是是在这个指标是最高的。所以这个是抗氧化性。然后呢，进一步我们看一下这个抑菌能力。在这个整个抑菌能力的话呢，实际上是也不一样的。在抑菌能力的时候呢，我们湿碱容易，比如讲对这个湿碱容易就 DIS 的话呢，我们这个抑菌活性实际上是最强的。17的话是我们的那个湿酸溶液的话呢，就是那个呢是最强。这个呢是我们的那个这个呢是我们做这个抑菌这个活性这方面的研究。进一步的话呢，我们 就比较了这个4种成分对海拉细胞的这个整个一个抗癌的活性。在这种在这种我们看一下我们 CIS 的话呢，就是呢分子量最小，然后呢溶解提取的，我们这个对海拉细胞的话呢，这个抑菌活性对这个抑制癌细胞增殖的话呢是非常活性最强。如果我们在座的各位你要做过这个多糖对这个癌细胞的处理，我们很可能会发现很多多糖实际上呢对癌细胞是有一种保护作用的。这个可能做过的老师的话，同学可能有这方面的经验。很多的多糖的话呢是有癌细胞呢它实际上没有抑制，反而呢是一种这个保护。包括我们实验室做的其他的呢也有的成分是一种保护。例如讲我们做枸杞多糖那个，反正这可能不同的人做是不一样的哈。实际上呢我们这做完之后我们就对整个一个当然了，这 RC50 值应该让 RC50 值浓度是非常的高。我们这地方我们列出来 RC50 例如讲532这种微克每毫升，这种实际上呢实际上是非常高的了。当然了，我们进来也可能经常我们也看到大家做多糖的时候也是这个浓度都非常高的。我们进一步呢我们做一下这个mRNA 表达，做一下这个 Western blot 看蛋白的研究，做一下这个方面。在我们在这个时候呢，实际上我们进一步的话呢，在我这样结果我没有显示，我们进一步利用这个多糖进行一个修饰，例如讲硒化修饰或者甲基化修饰或者这个等等这方面修饰，这实际上可以明显这个提出来，明显可以提高我们的这个活性。因为我的题目是讲在食品上利用，所以在食品上利用的话呢，我整个把黄金作为一个总结。这个总结的话呢，首先我们是经典的话呢，实际上是黄金，只是主要黄金研究还是我们的国内研究，经典的话主要是作为一个重要这个。另外呢，现在我们作为一个功能性的，我们在我们多糖啊，这个皂苷啊，还有这个蛋白啊等等，这方面我们研究的是比较多，是作为一种同时的话呢，作为这种利用我们这个多糖利用这个皂苷这种成分做成一种生物基的材料，作为一个进一步的话呢，我们是在食品当中的利用，这是我们最后的这个总结。我看了一下前面人超过10分钟，我就节约个5分钟。我报告呢就这样，就是当然了，这工作都是研究生做的。就感谢各位，感谢组委会给我一个报告的机会，也是非常抱歉。讲中文的话，因为我考虑还是讲中文还流畅一点。谢谢各位啊。主持人，我报告的就这样。
特别感谢韦教授，感谢韦院长，非常精彩，也让我们了解到更多的这个关于黄金这个宝。我们看到其实在这个 chat 里面有很多 question， 那我就先用英文念一遍，然后再用中文，这样由韦教授来回答。请问用于抗癌实验的皂苷分子量是多少？可能的靶点会是什么？What would be the dose for this sampling? And what will be the 我觉得我也不行。
我没关系，我正在看我的我正在把人家问题调出来啊。
好。
稍等啊，我正在把这个 Zoom 的话我还不太熟悉，然后我正在找刚才可以看到提问分子量的话呢，实际上呢应该是在200多，具体数字我记得不太清。应该我们做的是分子量应该是200多，然后多糖的话呢多糖我们做的是分子量最小的那种，就是溶解提取的那种多糖，实际上是560几多少的多糖。
好的， 感谢韦教授。还有一个问题是 ，How do polysaccharides enter the body to play an antioxidative roles？ 这个多糖是怎么进入到这个人体中，并且能够起到抗氧化的作用呢？
实际上多糖的话，这个作用机理，真是非常复杂。为什么呢？包括我跟我们多糖做，目前国内多糖做的非常好的聂少平教授，我也经常跟他去讨论这个问题。客观的讲，多糖分子量这么大，它到底是跟我们细胞膜上面的受体或者细胞它有没有受体，这不敢讲。到底是怎么样跟细胞进行结合？按照道理的话，它分子量这么大是进入不了细胞的。它进入不了细胞的话，它怎样起作用？实际上呢，我经常聂少平有时候也跟我讨论这个问题。他是所以讲客观话讲，你叫我讲多糖怎么进入细胞，怎么起作用，我真是答不出来。没有标准答案的，因为但是如果我们在写文章的时候，如果人家问这个问题，我们会讨论一大堆。比如讲，有可能是跟细胞膜上面受体结合，但是受体不清楚；有可能进入细胞，细胞也不清楚；有可能跟细胞表面的什么结合也不清楚。所以这个观点，所以实际上有一次聂少平他做过一次报告，他把不同的单糖然后组合在一起，然后结合在一起，然后模拟多糖，然后进行一个所以这个问题客观的讲我没有答案。我相信大部分大家都没有答案。如果讲有答案的话呢，那实际上都不科学的。我就是这么认为的啊。
Thank you, Dr. Wei. 还有问题是，有关于提到咱们这个产品在中国的这个工业化前景以及regulatory 就是这叫什么？就是咱们的法规规定，因为它隶属于可能是功能性产品这一类您是怎么看待这个工业化和法律法规方面对这方面的要求？
目前多糖的黄金的话呢，在国内主要都基本上都是作为它本身是药食同源，它是药食同源的一个成分，目前基本上都是作为一个初加工，然后进行吃的了。另外呢，多糖如果做过多糖的老师可能有经验，它的粘性非常的强，所以作为食品的增稠剂。在作为增稠剂的话的同时，它实际上也可以增加一些功能性的，是可以做这方面尝试的啊。
好的，感谢。那因为有一些我们还有我们这个最后一个问题，就是关于我们在生活中如果接触到黄金，无论是这个从植物还是说它作为一个添加剂添加到食品中，您认为什么样产品的形式的产品，或者是根据您的经验，可能是对我们身体带来的会带来某些功效，或者是更有效，就是产品的形态和产品的使用方法。
如果我讲的话呢，可能你实际上真正在我们黄金当中起作用的，刚才我讲多糖讲的成分讲的比重比较大，但实际上真正我认为真正起很多作用的还是次生代谢产物，例如讲多酚呐、黄酮。这地方我讲了皂苷啊，实际上都属于多酚类的。像这种多酚的话呢，实际上呢，在我们食品当中利用，它有个最大的缺点就是不稳定，容易降解。如果讲真正作为食品的话，我作为冷冻干燥完之后直接加到食品当中去吃，这种可能功效成分是最好。你要如果把一些成分提取出来，因为讲我们刚才你看很多成分提取的时候，很多成分提取因为我们是用高温的，因为讲我们这个多酚提取的话，它实际上它是用这个石油醚啊或等等，用石油醚提效果最好。这实际上它是有一定的危害，是有一定的残留，再加上高温， 所以可能对我们一些自身的一些产物啊，那个多酚啊等等是有一定降解作用。如果讲你最有效的吃法，就挖起来直接生吃，我认为是最有效的啊，直接生着吃是最有效。
感谢魏院长。Okay, thank you, Dr. Wei. It's a fantastic presentation, and it's very like a new ingredient for majority of the audience to understand its application of Huangjing and the mechanism of it. Okay, for the next, and I'd like to remind everyone here, we are a little bit like 10 minutes late for the presentation. Please pay attention to your time for the next speakers, and also please feel free continue leave your message and the questions to the chat. And now let's move, and also remind you, if please stay till the end, we will have a door prize and also social networking time. And now please join me to welcome Yanqi Zhao. So Yanqi Zhang is the third-year doctor candidate in human nutrition at the University of Alabama. She is mentored by Dr. Libo Tan. Yanqi's research focus is on the bioavailability and the biological activities of micronutrients and carotenoids, especially those associated with neonatal development. She is particularly interested in exploring encapsulation techniques that may improve the bioavailability and will optimize the functionality of biocompounds in neonates. Yanqi has 9 SCI indexed publications, 8 peer-reviewed abstracts, 7 oral presentations, and 5 poster presentations in national conference. She has just received funding from Sigma Xi grants in aid of research. Please join me to welcome Yanqi, and the floor is yours. Yanqi, can you share your screen, please?
Yes. Can you see my screen?
Yes.
Okay. Can you see my presentation slides?
I think you want to switch your model. It's not in a presentation mode.
Okay, I see. Second.
Yep, there you go.
All right, thank you. Hello, everyone. My name is Yanqi Zhang. I'm a doctoral candidate at the University of Alabama. Today, I will be presenting a study in which I developed a novel biopolymer-based lutein emulsion and show that the emulsion improves the storage stability, bioaccessibility, and in vivo bioavailability of lutein in neonatal rats. Lutein is a dietary antioxidant that can be found in dark green leafy vegetables and yellow-orange fruits. In the body, lutein acts as a powerful antioxidant that accumulates in the macular region of the retina, and it is a main component of the macular pigment. As infants lack enzymes to transfer lutein into other isomers, there is actually a significantly higher lutein concentration in the eyes of infants than in adults. In the eyes, lutein filters blue light and protects the retina of the infants when they are particularly vulnerable to light-initiated oxidative damage. Lutein has anti-inflammatory properties and is accumulated in the spleen, where it may play a role in the immune system. Emergent studies also show that lutein is important to the visual development and has reported it decreased the progression of retinopathy of prematurity, an eye disorder that is associated with oxidative damage and is leading cause of blindness in preterm babies. Despite lutein is so important, formula-fed infants had lower lutein concentration in the serum and eyes as compared to breastfed infants. Also, premature babies have compromised lutein status compared to full-term infants. A growing numbers of studies have been focused on exploring lutein supplementation to improve the lutein status in neonates and has obtained promising results. However, lutein application as a dietary intervention is limited by its very low oral bioavailability and stability. Lutein is poorly water soluble, resulting in only 10 to 50% of lutein being absorbed by the small intestine and reaching the target organs. Lutein is also a sensitive component and it's easily to be chemically degraded under heat, light, and oxygen, which can further limit its application in functional foods. Oil in water emulsion is a type of encapsulation technique, and it is a widely used one to improve the stability and bioavailability of lipophilic nutrients. Lutein can be carried by the oil droplets stabilized by biopolymers. While lutein emulsion system has been investigated in previous studies to improve the stability and bioaccessibility of lutein, none of these studies investigate the bioavailability of lutein emulsion in neonates. Therefore, the aim of this study is to develop a novel oil in water emulsion system for lutein that use food-grade polymers to improve the bioavailability and stability of lutein in neonates. Here, I use the neonatal rats as animal model. I used two types of oxinosuccinate starch, capsule TA, CTA, and high-cap HC, and one type of gamma-aerobic T-Commotion 3020 TM as bio-based emulsifiers. The oil phase are lutein in olive oil. Lutein emulsion was obtained by homogenizing an aqueous solution of the biopolymers with olive oil containing lutein in a ratio of 3:7. You will see the characteristics, storage stability, and in vitro bioaccessibility of lutein emulsion in the results. The encapsulation efficiency of lutein emulsion ranged from 78% to 92%, indicating a good encapsulation efficiency of lutein. Two animal studies were conducted, an acute study and a feeding study. In the acute study, 10-day-old rat pups, sprig dolly rat pups, were randomly divided into two groups and received a single dose of free lutein or lutein emulsion. At 30 minutes, 1, 2, 4, 6, 12, and 24 hours after a single dose, lutein concentration was measured in the blood. The pharmacokinetic parameters based on the serum lutein concentration and relative bioavailability were also calculated. In the feeding study, rat pups were randomly divided into three groups, in which they received a daily dose of olive oil, free lutein, or lutein emulsion from postnatal day 5 to postnatal day 18, which are 2 weeks. Olive oil is the negative control. At postnatal day 19, serum and selected tissues were collected, and lutein concentrations were analyzed using UPLC. Let's see the results. Figure 1 shows the confocal images of lutein emulsion stabilized by CTA, HC, and TM. The green color is because of the fluorescence of lutein. As we can see, homogeneous aggregate droplets were observed. The very small empty spaces between the droplets indicates a compact emulsion network, allowing them to interact intensively with each other and may further contribute to a good stability of the emulsions. The mean droplet size of lutein emulsions were ranged from 1.18 microliter to 1.445 microliter. The droplet diameter tend to normally distributed, as we can see from the figures, conforming a homogeneous droplets in the 3 samples. Figure 3, this figure shows the change of droplet size and lutein retention in the lutein emulsion stabilized by CTA, HC, and TM after a week of storage at 25 degrees C and 45 degrees C. After a week of storage at 25 degrees C, the mean particle size stabilized by OX starch CTA and HC did not change significantly, while gamma aerobic TI showed significantly higher droplet size than fresh samples. For the retention rate of lutein, to trace the retention, total content of lutein in the first time point was set at 100%. Free lutein was used as the control group. Lutein retention in the 3 biopolymer-based lutein emulsions was significantly higher than that of the free lutein. After a week of storage at 45 degrees C, the particle size of lutein emulsion was significantly higher than that of the free samples. Lutein emulsion stabilized by CTA, as indicated by the black line, showed a significantly higher lutein retention than that of the free luteins after the storage. After in vitro digestion, the release of lutein in the CTA and the TM based lutein emulsion was significantly higher as compared to the free lutein. Based on the in vitro testing, lutein emulsion stabilized by CTA was selected for these 2 in vivo studies. This figure shows the serum lutein concentration versus time after a single dose of lutein emulsions or the free lutein in red pups. As we can see, serum lutein concentration in both groups will gradually increase with time. The lutein emulsion groups showed a peak of serum lutein concentration at 6 hours, while the free lutein groups had a serum lutein concentration at a peak at 4 hours. At given time points, the lutein emulsion groups had significantly higher serum lutein concentration as compared to free lutein group. Based on the curve, the area under curve AUC was calculated. AUC can represent the bioavailability of lutein. The AUC was significantly higher in the pups receiving free lutein emulsion than that of the free lutein. The Cmax and Tmax were directly read from the curve. Cmax indicated the maximum lutein concentration, and here, compared with the free lutein groups, the Cmax of the lutein emulsion groups was doubled. Tmax is the time to reach Cmax. Interestingly, somehow, the lutein emulsion group had delayed Tmax than that of the free lutein group. Then we calculated the relative bioavailability. The relative bioavailability was 196% higher in comparison to the free lutein group. With the promising accurate study results, we conduct a feeding study. After daily dosing, rat pups receiving lutein emulsion show significantly higher lutein concentration in the serum, liver, eyes, spleen, and lungs, compared to those receiving a free lutein. The higher lutein concentration in the serum indicates more available lutein in the serum to be used. The liver is the main storage organ of lutein. A significantly higher lutein concentration in the liver in the emulsion group suggests that more lutein can be mobilized to other organs when needed. Also, as I mentioned in the introduction section, lutein is important in eyes and spleen, where it plays a role in the visual development and immune systems, respectively. Lutein concentration higher in these functional organs in the red pups in the lutein emulsion groups may suggest that better lutein functionality in these organs. Furthermore, neonates is a critical period for lung development. So high level of lutein in the lung may be beneficial to this critical stage. We did not find significant difference among groups in other organs. In conclusion, lutein emulsion stabilized by OI starches CTA has overall best stability in droplet aggregation, color retention, and in vitro release. In addition, lutein emulsion stabilized by CTA improves the concentration of lutein in circulation and in its functional organs, such as eyes and spleen. Therefore, the oil in water emulsion stabilized biopolymers could be a promising carrier for lutein to expand its application in infant foods. At the end, I would like to thank my amazing mentor, Dr. Li Botan, for her support and guidelines of this study, as well as Dr. Lin Yankong for his contribution to the presentation and the preparation of lutein emulsion and in vitro part of the study. And thank you all very much. Any questions?
Thank you, Yanqi. Very nice presentation. I like your passion in terms of presentation and also the results. It's amazing. I think we have a few questions in the chat box. I'll try to summarize it. The first questions comes from does the Zengold consist of the both lutein esters and free lutein? Is there any difference of solubility and stability between free lutein and the esters for emulsion?
Can you repeat this question? Because I did find the question in the chat.
Yeah, maybe it's directed to me, the question. Okay. Oh. Okay, I think Xiao Chao just retype the mess in the text box.
Okay. Okay, I see the question. Thank you, Xiao Chao. And for the first one, does a single consist of both lutein ester and free lutein? So when I prepare the lutein emulsion, I just calculate the lutein content based on the lutein esters. In the product, it has the how many what's a percentage of lutein esters in the product. And for the solubility and stability between the free lutein and esters in lipid droplets, so I think there are slightly different because I learned from the previous studies that the lutein ester is more stable under room temperature. However, in my study, I only used the single product which contain lutein esters, and so basically the stability was tested on the lutein esters. Thank you.
Thank you. And we got another question from Professor Chen. Why did emulsion have higher Tmax?
Thank you, Dr. Chen. This is a good question. I will think about that for a long time because from some other studies, that they have like different results. So my explanation for now is that there is interaction between the transport protein and the formulations. So I think that's why we got delayed Tmax in the in the lutein emulsion groups. Yeah. I hope
think
that
we got a lot of questions from expert. I see another expert in this area. Dr. Zhou Hualu asked, my question is that have you tried the combination of free lutein and oil? What's your expected?
So for this one, are you talking about the bioavailability or the stability? Because for the free lutein I use this study are all free lutein dissolved in the olive oil. So basically, my control group is the lutein sample dissolved in the olive oil, and my treatment group is the lutein emulsion group.
Yeah, thanks, Dr. Zhou. I think she will ask a follow-up question later in the chat to elaborate more about the detail. And we got another question. Does lutein demonstrate similar absorption and elimination pattern in human, like similar half-life elimination rates?
So I guess this question is similar absorption in the red pups as compared to like human infants. So I
Yes.
Okay, yeah. So I think the reason we use animal models is because that it can mimic the absorption rate in the humans. So my answer for now is yes, it will have a similar absorption, but I think for the human, we need to consider other factors such as the food metrics and like some more oils or some other foods may increase absorption of lutein. But I think the half-life and examination rates will be similar. Yeah, thank you.
Got it. Another question. Do free versus emulsion forms of lutein have the similar or same route of the absorption based on your hypothesis?
Yeah, I think the free lutein and the lutein emulsion will have the similar rates of absorption. It all will be taken by the small intestine and transferred to the serum or the lymph for absorption. However, as I mentioned, due to the different formulation, the lutein emulsion may be carried by the different amount of transport proteins that will influence its absorption. Yeah.
Got it. I think you have a lot of questions in the chat, and I would highly encourage you to reach out to the either like for people who would like to continue connect with Yanqi and or connect with the expert in the chat who asks you the question. I think it's a good opportunity, and we would like to. That's one of the major objectives, to have the platform for the student to present their research and also exchange ideas and learn more opinions from the experts who might provide a lot of suggestion to Yanqi. Thank you, Yanqi. Excellent presentation.
Thank you.
And with that, I'm gonna move forward to our next speaker, Xueying Lin. So Xueying Lin is a junior student majoring in food and nutrition science at Macau University of Science and Technology as a teaching assistant in MUST. And she mainly focused in courses of basic chemistry, organic chemistry, and biochemistry, and molecular biology. And she participated in the 3 Squirrel Cup Leisure for Food Innovation competition and won the 3rd prize. And thank you, Xueying, and the floor is yours.
Thank you. Can you see my screen?
Yes.
Okay. Thank you for your introduction. And my name is Lin Xueying, a junior student of Macau University of Science and Technology. I'm so honored to have this opportunity to attend the conference. The title of my presentation is Edible Insects in China, Application, Value, and Prospects. As you see, I'd like to divide my presentation into 7 parts, and I will introduce each of them. In the first part, I'd like to talk about the background of our review. Nowadays, China is facing 2 challenges of tackling malnutrition and ensuring food security. Healing hunger, a form of malnutrition, occurs when the quality of the food consumed does not meet nutritional requirements. In China, deficiencies of iron, vitamin A, and other nutrients are a common problem among key regions and key populations. In terms of food security, China has met the standards set by the Food and Agriculture Organization by the United Nations. But from the perspective of nutritional need and food quality, China's food security issues depend on protein production and supply. However, the protein supply is lower than the healthy target protein demand. At the same time, Chinese dietary patterns are shifting from a diet-based to an animal-based diet, which will lead to an increase in food demand. In addition, climate change will seriously affect food production. These issues will pose a threat to China's food security. According to previous research, many species of insects are nutrition-rich, and it can be a healthy food source for humans. Before introducing the various values, I'd like to start by China's connection to edible insects. Edible insects has a history of more than 2,000 years in China, and there are about 1,090 kinds of edible insects in the world, as shown in Figure 1. Of these, 324 recorded species are related to food and feed in China, and are shown in Figure 2. They include common edible insect species, some less common edible insect species, and some medicinal insects. There are only 10 to 20 commonly eaten species popular in China, like bee, silkworm, cricket, and so on. Next, I would like to introduce the value of insects. Let's start with its nutritional value. Many studies have shown that insects have high nutritional. The protein content of insects is usually higher than that of most plant and animal products. It is reported that the protein content of most insects is more than 60%, and the digestibility can reach 75 to 98%. Besides, good amino acid ratio in insects meets the requirement of the World Health Organization. Secondly, unsaturated fatty acids are dominant in insects, and the ratio of saturated to unsaturated fatty acid is between 0.43 to 0.79, which is more beneficial to the human body. Thirdly, insects have high content of vitamins. To be specifically, insects have mainly contain carotenoids and vitamin B2, B5, B6, B7, D, E, and K. Next nutrition I want to say is mineral. Insects generally contain minerals such as iron, zinc, sodium, calcium, and so on. Last but not least, the content of carbohydrate in insects is low. Chitin is the main carbohydrate. In addition to their nutritional value, edible insects can provide economic and environmental benefits as they appear to be a more sustainable and environmentally friendly source of nutrition than other animals. Let's start with its environmentally sustainability. China has been listed by the United Nations as one of the 13 water poor countries. The agriculture, as a major water user, consumes more than 62% of China's total water consumption, of which the production of animal products accounts for the majority. To produce the identical amount of protein, insects require less water than the farm. Animals let's move on the greenhouse gases emitted. China has been very considered about their greenhouse gas emission and is committed to working toward carbon neutrality by 2060. But life cycle analysis found that 9% of the world's carbon dioxide, 35 to 40% of methane, and 65% of nitrous oxide production are associated with the entire production process of animal products. The result is that livestock is currently one of the main contributors to the greenhouse gas emissions. Studies have shown that insects have much lower greenhouse gas emissions than large livestock. Meanwhile, cricket and locusts can produce 100 times less greenhouse gases than the beef, cattle, and pigs. Therefore, insects can be a more environmentally friendly source of animal protein. High feed conservation efficiency also plays a role in this, since the growing meat demand requires more sources. Chicken, pork, and beef require 2.5, 5, and 10 kilograms of feed for each additional kilogram of weight, respectively. while cricket only needs 2 kilograms of feed for each kilogram of weight increase. The conversion of plant protein into insect protein can be much more efficient for insects than it can for mammals. Therefore, insects are much more economical than traditional livestock. Next, I would like to turn to economical benefits. The first aspect which I'd like to mention is insects have the promise of becoming cost-effective nutritional substitute or supplement for humans. With the demand of meat, egg, and milk increasing, it is a challenging issue to supply sufficient protein from conventional livestock, poultry, and fish. Many insects are promising nutritional edible substitutes or supplements owing to abundant nutrition content, environmental sustainability, and easy mass reproduction. After that, let's focus on green feed for livestock, poultry, and agriculture. Farming edible insects with high protein content as green ingredients for feed processing will lower corn and pasture consumption, dedicated to livestock, poultry, and agriculture. This will be good for ecosystem and biodiversity. China has made many efforts in agricultural production to ensure food security and nutrition. But agricultural expansion may be accompanied by the consumption of pesticides and fertilizer, which can deteriorate the quality of water, air, and soil. What's more, edible insects can also be an ideal choice for sustainable organic waste management. Let's look at figure 3. One sustainable organic waste management choice to recycle these wastes is bioconversion of them by some edible insects, which can change organic matter in wastes to high-value feed and feed ingredients, green fertilizer, bio oil, and so on, resulting in little energy and nutritional drain and wasting. Last but not least, insects are used as industrial and pharmaceutical raw materials. Silk, the product of silkworm, play an important role in textile industry and export products. Cochineal use the carmine acid used as a red dye in human food as well as in pharmaceutical and cosmetic industrials. In addition, a total of 239 species of insects are used in pharmaceutical films. We just shared the many benefits of eating insects, but as more and more attention, we need to consider the obstacle we will encounter in using it. I'm going to start with their food safety and potential hazards. Internationally, the safety of insects is considered through 4 main aspects, which are physical, chemical, biological, and allergen. In China, we go through procedure for toxicological assessment of food to assess and determine food safety indicators. As of 2019, only 34 species of insects have been evaluated according to the procedure for toxicological assessment of food in China. Study conducted on evaluation of traditional edible insects in China, including acute tests, genotoxicity tests, and 30-day feeding tests, suggested that most of them are non-toxic. During the period 1980 to 2007, and review of allergen cases caused by food consumption in China revealed that insects were the 4th most commonly reported allergen. Judging from the current consumption rate, the safety of insects is not yet a major issue. However, the safety of common edible insects in China should be taken seriously as the concept of edible insects is promoted. We will now come to consumer acceptance. The low acceptance of insects is one of the major obstacles to promotion of the edible insects. For most countries, disgust and foodnophobia has the most significant negative effect on willingness to purchase. Although the same is true for China, the impact of these two factors are less significant. we constructed a model to better interpret it. From a psychological perspective, the fundamental differences between Chinese and Westerners is they share different associative networks, which elicits more positive emotional react on insects for Chinese. That contributes greatly to the willingness to buy and eat insects. According to the research, Chinese potential consumers have their own characteristics. A cross-cultural research shows that for Germans, they pay more attention to the appearance and flavor, while stressing the effectiveness of insects as a tonic has little influence on their willingness to eat. However, more Chinese would like to take it only for its extra health benefits. Chinese has comparatively higher willingness to eat and purchase insects. They have a lower food phobia and a lower level of disgust. Stressing more importance on additional health benefits of insects and carry-related knowledge is helpful for increasing the acceptance of edible insects. Through this review, we hope more and more scientific research and social concerns are attracted to strengthen the culture and utilization of edible insect research in China. If so, proper legislation and quality regulation for food and feed from insects should guarantee. The food safety of insects has not been thoroughly studied and need to be further evaluated. Mass insect farming to get cost-effective industrial is also needed. Lastly, more widely acceptable processing techniques are also necessary. That's all my presentation. Thank you for listening.
Thank you, Shane. Let's see, very interesting topic. And let me look at the chat and to see, apparently there are a few questions regards to the alternative source of protein, and it have been applied into either food or human food or animal feed. So the questions is, have you ever calculated the profits of this edible insects in China?
Oh, that's an interesting question. We've learned a little of this, but we can look at an example. According to a news, China is the largest producer of being produced in the world and ranked first in the annual output of beef products. According for more than a quarter of the world's total output, the production is deeply welcomed by consumers in Thailand and Polish, as healthy food are developing rapidly in the national market. In China, as far as I can remember, there are more than 2,000 integrated processing and trading beef products, and the total output value of these products exceeds 30 billion yuan. So that's my answer.
30 billion.
Yuan, yeah.
Got it. Nice. And also, is there any concern of bioaccumulation of this pesticides, insects that cause any issue in terms of food, for human beings as a food?
Sorry,
the pesticides. So people apply pesticides into the pets, in those insects. And maybe somehow there are residuals in the in the insects, and then it turns into a food. So there could be some accumulation.
Yeah, it is, and also a question of the food safety of insects. But I cannot quite remember. Maybe I need to do a little checking and go back to you.
Sure, yes. And also another question from Dr. Godongma is that for nutritional benefits and environmental sustainability, this is a very cool topic, and is the information include all kinds of edible insect or just one kind of edible insect? What would be your research focus? It's all the data is in general or specific to the insect group?
In general or insect group? Actually, this
Go ahead.
This review, we general research the insect we can find. It's not only just a kind of species, but actually the research are mostly focused on crickets, meanwhile, so we still need more research on other insects.
Sure. I'm pretty sure there are a lot of topics you haven't covered. And we also got a question regards to, so as you know, as alternative protein source, insect is only one. And there's also plant-based, micro-based, so compare with the other source of alternative protein. What's your opinion or vision of this insect protein strength is compared with the plant protein or microbial fermented protein?
The plant protein or the insect protein, can see the content. Actually, the protein content the insect protein content about 60%, and its digestibility rate 75 to 98%. I think it is a high rate, and besides, compared to other animal protein, the insect protein has their environmental sustainability advantage, like they need less water, they emit less greenhouse gases. I think this is the protein, this is the insect protein advantage.
Yeah, I think that's a really good question. Probably the audience will highly suggest you to consider, because it's a very popular topic. It would be great to have a table to compare your insect protein research versus the other alternative source protein. What are the nutritional bioavailability, and also maybe their cost and their sustainability, all those kind of data in a table format or in a chart format, and then that will be more clear, for people out of this research might have a better understanding.
Yeah.
Yes, and also we got another question, so it's more kind of sensitive and really to the religious, because some of the culture they might not eat insect at all, or some religions might try to avoid that. Have you done any research or study on it?
Yeah, this is a problem, but for China, the religious aspect is relatively minor. China.
Yeah, we have a long culture and some region really okay with eating insects. Is that what you're trying to see?
Yeah.
Okay. Yeah, thank you. And I appreciate all the questions. So with the time, we have to move forward to another speaker, but really good work. And we are looking forward to have more follow-up questions regards to this topic. And allow me to share, introduce our next speaker, Xinge Hu. So Xinge Hu is a first-year doctoral student in biomedical nutrition science students in the University of Tennessee, Knoxville, and she obtained her BS bachelor degree in biochemistry and master in cellular and molecular nutrition in the University of Tennessee, Knoxville. and mentored by Dr. Guoxun Chen. Yeah, thank you, Dr. Guoxun Chen, for recommending your students to come. And their lab focused on the possible prevention and treatment for type 2 diabetes with vitamin ACE under high-fat diet setting. With that, I would like to please Xinge, the floor is yours. Please share your slides.
One second.
And I guess Dr. Guoxun Chen will have a lot of, won't ask any challenge question, right, Dr. Chen?
Hello, everyone. My name is Xinge, and I'm a graduate student in Dr. Guoxun Chen's lab in the University of Tennessee. And today my topic is switching palmitoyl and oleoyl position in SN2 and SN3 of a triacylglycerol lead to differential body weight, gain rate, and hepatic gene expression in mice fed with a high-fat diet. So first, I want to start with a little bit background of dietary lipid. It can come from both animal and plant product like butter and coconut oil. Lipid has the highest energy density among all three macronutrients, and it should fulfill 20 to 35% of one's daily calorie intake. Excess energy will be stored in the white adipose tissue. At molecular level, lipid also function as signaling molecule to regulate a variety of pathways, including appetite, fuel homeostasis, blood clotting, and help regulate body temperature. Lipids such as phospholipid and cholesterol will act as major structure component of cell membrane. Triacylglycerol, which is a major form of dietary lipid and a member of glycerol family. In human, TAG contribute to cellular energy balance, lipid homeostasis, support normal growth and maintenance. But TAG's main role in cell is to function as one storage form of energy. And due to the special structure of TAGs, different on the fatty acid group will lead to variety of different TAG structures. Fatty acid group could have different lengths, different number of double bonds, and different position of the double bond. And there are two main ways to modify the structure of TAGs. One is through fatty acid randomization, and one is through fatty acid interesterification. Now I want to briefly talk about the metabolism of TAG. So the small intestine is the primary absorption site for TAG, and it enters the intestinal cell as free fatty acid and got re-esterified to TAG. Dietary glucose enter liver through portal blood, and de novo lipogenesis took place there and start to generate TAGs. Eventually, chylomicron carried with dietary TAG and VLDL carried with de novo synthesis TAG will enter the venous blood, go through heart, and arrive at adipose tissue and muscle. When arrive at adipose tissue, free fatty acid will be uptake by adipose tissue and re-esterified to TAG and stored for further energy use. When the TAG arrives skeletal muscle, free fatty acid will be uptake by muscle cell and used as energy. Excessive free fatty acid will be re-esterified into TAG and stored as IMTG. Eventually, chylomicron remnant and IDL or LDL carry leftover glycerol circulate back to liver through arterial blood. And here is a picture of de novo lipogenesis pathway. So after a carbohydrate-rich meal, de novo lipogenesis took place in liver, and this is a process of generate palmitate using glucose. After glucose enters cytosol via glucose transport protein, it will go through glucolysis and generate pyruvate. Pyruvate then enter mitochondria and join Krebs cycle and then release citrate. After citrate left the mitochondria and re-enter cytosol, it will enter the fatty acid synthesis pathway. Citrate will be converted to acetyl-CoA. The acetyl-CoA will be converted to malonyl-CoA with ACC. Malonyl-CoA will be converted to palmitate with FAS, and then palmitate will be further converted to palmitoleate with SCG1. So the reason why it's important to study lipid metabolism is because it's deeply related to human health, including metabolic syndrome. Metabolic syndrome is is a combination of multiple conditions that occurs together, which including insulin resistance, hyperglycemia, dyslipidemia, hypertension, and obesity. The obesity rate in US has increased from 30.5% in year 2000 to 41.9% in year 2020. Previous study demonstrate that metabolic syndrome largely contribute to cardiovascular disease and stroke, which is the first and the third leading cause of death in America. Insulin resistance and obesity most definitely contribute to the development of type 2 diabetes, which affect around 37.3 million people in the US. And patient does not have to undergo all 5 conditions to be diagnosed with metabolic syndrome. As long as they have 2 out of the bottom 4 condition plus insulin resistance or type 2 diabetes, they will be diagnosed with metabolic syndrome. And the structure difference affect the TAG in many aspects, including physical, chemical, and physiological property changes. It will affect the melting and crystallization point for the fat or the solubility and absorption rate. Previous research showed that saturated fatty acid on the SN2 position are better absorbed and result in slower chylomicron clearance rate. At the same time, modified fat can also affect food intake and body weight in mice. So from the left side of the slide, you can see there is 2 TAG structures, and those are the 2 TAGs we used in our study. The top one, PPO, is synthesized by fatty acid interesterification, and the bottom one, POP, is purified from commercial palm oil, which is the more natural form. And the only difference between these 2 TAGs is that the oleic fatty acids switched from the SN2 to SN3 position. So the knowledge gap here is that due to the feature differences, modified TAG are commonly used in different fields, including in clinical setting, food industry, and especially in bakery and formula milk production. Many study has been focused on the synthetic techniques and the chemical properties of several modified TAGs. However, there are only limited in vivo study has been done that talk about how does the TAG structure change would affect body weight or food intake or blood glucose and other lipid parameters in vivo, and we also don't know how would the change in TAG structure would affect lipid metabolism and protein expression in metabolic active tissue and cell. So in our experiment, we used the 27 male C57BL6J mice, and they were randomly separated into 3 dietary groups. The first group is fed with the CHO diet and used as a control. The second group is fed with 36% weight by weight PPO fat mixed with the CHO diet, and the third group is fed with 36% weight by weight POP fat mixed with the CHO diet. During the 6 weeks treatment, the food intake and body weight were measured daily. And after the 6 weeks treatment, we sacrificed the mice and collected the serum, liver, and epididymal fat. So as a result, we first look into the weekly food intake and body weight gain. We found that the PPO group start to have a significantly higher body weight gain at the late stage of the experiment, which is week 5. Interestingly, at the early stage of the experiment, as early as week 2, the PPO group already start to have a significantly higher calorie intake than both POP and the control group. Now, if we look into the total food intake and calorie intake throughout the experiment, we found that the control group have the highest food intake in gram among all 3 dietary groups. Then the PPO group have a higher food intake than the POP group. Due to the energy density difference between the high-fat diet group and the control group, the PPO group have the highest calorie intake, then the POP group have a significantly higher calorie intake than the control group. Now we start to look into the body weight. The PPO group only significantly higher than the control group, but not to the POP group. However, due to the different initial body weight, the PPO group have a significantly higher body weight growth rate throughout the experiment in percentage than both control and POP group, and there is no difference in control and POP group. Next, we start to look into tissue composition of the mice. Both high-fat diet group have a higher epididymal final epididymal fat weight and epididymal to body weight than the control group. But for the liver, the control group have a significantly higher final liver weight and liver to body weight percentage than both high-fat group. But interestingly, POP group actually have a significantly higher liver to body weight ratio than the POP group. Here is the result for serum metabolic parameters. Both high-fat diet group have a higher total cholesterol level than control, but no difference in between. The PPO group have a significantly lower serum glucose level than both control and the POP group, but no difference in between. And even though both high-fat diet group have a trend of having higher serum TAG level, the result is not statistically significant. Finally, we start to look into the expression level of lipogenetic protein. So the control group have the highest ACC and phosphor ACC level among all 3 groups, but the PPO have a significantly higher ACC protein expression than the POP, but the POP group have a significantly higher phosphor ACC than the PPO group. The control group also have a significantly higher CD36 and fast protein expression, but there is no significant difference between the 2 high-fat diet groups. We also find that the POP group have a significantly lower SCD1 protein expression than both control and PPO group. This is very interesting because SCD1 is in charge of the catalyzation, the synthesis of monounsaturated fatty acid, and SCD1 is also a rate-limiting enzyme related to lipid metabolism as well as insulin signaling pathway. Now we look into insulin signaling pathway, glycogen, and cholesterol-related protein expression. We found that the control group have a significantly higher IRS1 protein expression than both of the high-fat diet group, but we didn't saw any significant difference on IR beta, AKT, and HMG-CoA reductase among all 3 dietary group. At the same time, the control group only have a significantly higher GS protein expression than the PPO group, but not to the POP group. However, for the phosphor GS, both POP and the control group have a higher PGS, phosphor GS protein expression than the PPO group. And here is a list of, in summary, here is a list of our study. We've found that between PPO, which is the modified form, compared to the POP, which is the natural form, the PPO group have a higher calorie intake start at week 2, a higher total food intake, and a higher body weight gain start at week 5. The PPO group also have a lower liver to body weight percentage and a lower serum glucose. For the protein expression, the PPO group compared to the POP have a increased ACC protein expression and a decreased phospho-ACC protein expression. PPO group also have a increased SCD1 protein expression and a decreased phospho-GS protein expression. And our study demonstrates that different fatty acid group at SN2 position will alter the phosphorylation of ACC as well as the phosphorylation of GS and the protein expression of SCD1. We think that the difference is caused by the different breakdown sequence. Since the breakdown of TAG start as the fatty acid group at SN1 and SN3 positions, the different TAG structure will lead to different breakdown sequence. For example, POP breakdown will result into 2 palmitic acid. Each will go through 7 cycles of beta oxidation and then each produce 8 molecules of acetyl-CoA. However, for PPO, the breakdown will first result in 1 palmitic acid and 1 oleic acid. Oleic acid will need to first go through isomerization and then start beta oxidation and result in 9 molecules of acetyl-CoA. For extra isomerization step, it will consume glucose, and this might be why the PPO group have a lower blood glucose level. So in conclusion, our study demonstrates that the alteration of fatty acid group in 1 TAG molecule could alter the appetite and body weight in mice. The fatty acid location will affect the liver to body weight ratio in mice, as well as the serum parameters and expression level of genes involved in lipogenesis, such as SCD1. And here is my reference, and I would like to thank Dr. Tony Wang in Food Science Department in the University of Tennessee for providing the fat we use in our study. That's it.
Thank you, Single. Very nice presentation. I would like to give this opportunity, invite Dr. Chen to host the question section. I think no one will understand more better than Dr. Chen. Please.
Okay. I think that one from the first question that is one question in the chat box, which is the have you got a chance to measure changes in liver inflammation?
From me?
No. We
have not done that yet. Yeah.
Yes.
Okay,
Not
great.
yet.
Thank you.
Maybe more questions on the way.
So probably I just add another question, can I?
Yeah, go ahead.
So when you look at the lipogenic expression, so because it's too small for me to see, have you ever checked the difference in the 2 transcription factors? What I mean is CHABB and SIBB1C. Are they differentially regulated or simultaneously regulated by the 2 different diets?
I don't think we did Western blot on the 2 you mentioned. I think I tried to do SRBP1, but I don't think I have a result for that.
Okay, great. Thank you. So probably Dr. can provide some insight. I mean, if not this time, probably afterwards.
Yeah. Well, we did not have a good antibody, first of all. And I know that SIBP1C's antibody it's not easy to get a good one. That's our main concern. And we have not checked the CHI-EBP because we should. And if I would like to actually, if we can do it, we would like to isolate nucleic extract to measure those.
That could be very useful as another related question is actually, so have you ever think about to treat primary hepatocytes with two different, POP, so sorry, I may got it wrong, or another fatty acid to see. So look at this Lipogenetic related event. That could be very exciting study. Just some comments.
Yeah, I don't think, Shingo, you want to answer? We did not do that. We didn't
do any in vitro study yet.
Okay, good, but very interesting. Thank you.
There is one more question. Did you investigate expression of different lipids in human body? Wait. Shingo, you want to answer that? We did not.
So we did not, and I don't think the lipase. There are different lipase involved in the. Let me show here. There are different lipoprotein lipase and LPL involved in this progress, but I don't think it's highly specific. And different lipids have a variety difference, but we didn't test the lipase activity at SN1 or 3 or in SN2 position. Do we think POP is healthier than PPO? It depends on the goal. If someone has to intake a large amount of lipid but hope to decrease the blood glucose, then in this case POP is, where is the slide? PPO is healthier, but in other case, maybe not.
Yeah, we did not investigate in humans. We only use animals in this study. And this is a very interesting observation because we always think about a high-fat diet. The truth is the location of those fatty acids probably also play a role. They will regulate our metabolism differently. Well, not ours, animals, in this case, mice, right? I agree, they probably digested at a different rate because they have different physical chemical properties. For example, melting point probably slightly different. And in addition, we observed, as shown by Xinge, we observed the free fatty acid and 2 monoacid cholesterol and into the small intestine cells, and then our small intestine cells re-esterified them. And so therefore there is a subtle difference there because we observed for the PPO, we observed the palmitate, the saturated fatty acid at the SN2 position. We observed the oleate for the POP, which is a monounsaturated fatty acid at the second position. And those two differences could be responsible for some of the phenotypes we observed here. So that's a good question. And what is the current status in the designed lipid area? It was quite hot a couple of decades ago. Yeah, the structural lipid study, I think has more applications in food industry, and I think it is still probably a hot area in food industry. I think Shelly probably can add something here.
Yeah, I to be honest, my background is protein. I won't see. I won't pretend that I know this.
Okay. Okay. Here's what I know is that, for example, many people want to say we need to drink human milk, right? But for the infants, not us. Okay. For the infants, they drink human milk. Human milk, you try to mimic. If you try to make a formula and mimic human milk, what do? You try to put those fatty acids in the correct place. So it's exactly like human milk. This is something that relates to what we're showing here.
Yeah, thank you, Dr. Chen. I think this is kind of very closely to the next topic regards to the dairy, because HMO is also very popular in terms of this topic of structural lipids. And within that, I would like to thank you, Xinge and Dr. Chen, for excellent presentation and question section. In terms of timing, I'm going to move forward to the next speaker. And please allow me to introduce Dr. Dongjie Chen, which is a fantastic scientist, and also he is currently working for NUFE as a technical and business consultant. Dr. Chen completed his PhD and postdoc from University of Minnesota. His specialties include food science, environmental and chemical engineering, and Dr. Chen has published 33 SCI academic journals and 3 academic books, 1 US patent, and 102 plus referred article, and more than 1,200 academic citation. Within that, I would like to invite Dr. Chen to start sharing your screen and looking for your talk.
Thank you for the introduction from Shelly. I will also share my screen right now. Okay. Good evening or morning, everyone. It depends on where you are. My name is Dongjie Chen, and it's great to give a presentation in the NACAN on behalf of NUFE Dairy and Innova Boston. And the second authors, Chimini and his R&D teams in China. So I will give the presentation on the behalf of NUFE Dairy. And the topic of my presentation is characterization of new generations of dairy product, 活润 crystal ball yogurt. And the first is I will give the research background. Yogurt has remained commonly used dairy product in daily food of the people in India, Central Asia, and the Middle East region, Central and Southeast Europe until 1900s. Yogurt was first made in the United States in the first decades of the 20th century. The productions being boosted by the writings, prolonging life, optimistic study by Ely. A new technology was developed in Switzerland only after 1950, which led to the marketing of the fruit-flavored and sweeteners yogurts. And the encapsulation yogurts began in 21st century. The NUFE Dairies launched the product 活润 in 2020. The product enabled the probiotic to be delivered to the target gut successfully. Here is the background of what's on the probiotic. Probiotics are represented by a wide range of microorganisms and the field of bacteria, genus Lactobacillus and genus Bifidobacteria. And many other probiotics are used predominantly in yogurts. Administrations of probiotic bacteria stimulate the growth of beneficial gut microbiotas, crowds out the potential harmful bacteria, and reinforce the body's natural defense mechanisms. Probiotic efficiency is equal to the probiotic capacity multiplied by the number of live bacteria reaching the intestine. That's a very important equation, so I highlight here. And due to the challenging production process of encapsulation probiotic, And you can see in the picture is the first generation encapsulation probiotic and has low excellent physical stability in stomach or bile salt. So only a few probiotics can be delivered to the target gut in human bodies. And we can also see the second generation technology is ordered by Shensha company. Also, the issue has been resolved in the second generation of the encapsulation probiotic product. The capsules cannot last in yogurt for a long time. On the other hand, the processing cost is pretty high, and therefore, on the basis of the previous lessons, the third generation's encapsulation probiotic is exclusive technology for little dairies in China. Its product, Huarun encapsulation, is equipped with the features of low cost, fast operation, condensed probiotics, and excellence in physical stability. So let's focus on the Huarun's encapsulation probiotic product. It has a very beautiful name, Huarun's Crystal Balls Yogurt. And in April 2020, Yuhou Dairy launched the industry's first Huarun's Crystal Yogurt, which is chewable probiotic as the main selling points and the concept of probiotic body yogurts. And you can see the three functional probiotics are added in the yogurts. And we'll give everyone videos introductions of how much probiotics contains in the encapsulation.
Dr. Chen, we can't hear any sound. Would you like to or explain verbally, please?
Yeah, there's a subtitle here. And if the audience cannot hear the voice cleanings, I will introduce the main ideas. And this videos introduce the IV crystal balls in the yogurts can contain up to 20 million probiotic in the past, and the latest product contain up to 40 million probiotics. So that means the probiotic content is very high in the yogurt. In the yogurts in IV's crystal ball. And you can see this is the probiotic crystal ball. The first picture is the probiotic crystal ball diameters. It's about 5 millimeters. And the encapsulation has been used in the food industry for more than 7 decades. And the encapsulations involves either covering particles with a role in a diet, such as acidifiers, yeast and artificial sweeteners, and minerals, vitamins, antioxidants, essential oil, flavors, and others, or covering the whole ingredients such as the resin, nuts, or product. Active and protective ingredients forms homogeneous granulars. That's it. And the active products is evenly distributed in the granulars, being surrounded in abundance by the productive material. And so these form the active matrix. And the CBG bead is kind of calcium pectinate gel beads, and which is used as the barriers in the current products. The barriers, the protections against the oxygen, waters, light, and were in contact with other particles or ingredients, or controlled, and they are released over time. You can observe the chart. The calcium pectinate network inside, and is used to support to immobilize probiotic inside. And according to the the license from New Hope Dairies. They have a shelf orders, electrolyte properties, rice about the kind of probiotics, lactobacillus, rhamnus, GRX10. And he did the phase 1 clinicals and proof is useful in human bodies. And also then they conducted the research on the phase 2 clinical trials, and still use the lactobacillus rhamnus GRX10. So they use the results is randomized double blind, and also use the placebos as control in the human trial. And you can see that's the results with and without the probiotic GRX10. So GRX10 has the results of can reduce some blood lipid indicators such as TC, TG, and LDL levels. And safety feature also is very important for the lactobacillus rhamnus GRX10. So safety features include the following specific, such as they can isolate from healthy human GI tract on non-pathogenic, has no history association with the disease, doesn't deconjugate biosource and personal antibiotic resident gene. So in conclusions, after the whole gene analysis, GRX10 genomes wide data were analyzed, and the results indicated that the GRX is safe and potentially probiotic stream with multiple probiotic functions, including excellent trait such as the acid and the biosalt tolerance, bacterial synthesis, and good adherence characteristics. And then let's look at the tolerability. So probiotic crystal balls, we use two kind of probiotic streams in this study, and put the probiotic in the artificial gastric juice, and the pH at 2.5 and 3.0, and the treatment time is from 0 to 3 hours. And you can see the results from the figure, and the stream concentration in crystal balls of GX and LPC 37 only decrease 0.5 logs, while the stream concentrations of theirs show 2 to 3 log reduction, decrease in stream concentration without encapsulation. And if we put theirs in the pH at 2.5, the concentration of streams in GRX10 and LPX37 crystal balls decreased by 2 and 3 logs, while concentration of streams in the GRX10 and LPC33 decreased by 5 and 7 logs. So it can be seen that the crystal balls encapsulation significantly enhance the tolerance of probiotic GX and LPC33 to the artificial gastric juice environment. And then we put them in the biosalts. So for GRX10 and without encapsulation, the difference is 4 logs. And for LPC37 with and without encapsulation, the difference is 2 logs. Then we move on to the topic of the stabilities of the Horan's crystal balls yogurt in intestinal fluids. And probiotic crystal balls was completely degraded by continuous checking treatments in artificial intestinal fluid for 3 hours. So that means the probiotic is released in 3 hours. And after 4.5 hours of digestion in artificial intestinal fluid, viable bacterial count of GX and LPC in both crystal balls powder remained the same level, then 10^8 CFU per gram, and there was no significant difference in the survival rates of the streams in probiotic crystal balls and the powders. If that means the probiotic released after crystal ball encapsulation can still maintain their viable bacterial count in the intestinal fluid. And then we look at the shelf life of whole range crystal balls yogurts during the shelf life. And the shelf life away from 1 to 21 days. And we want to compare we want to invest the external probiotic, that's the probiotic, suspend in the yogurts. And then we want to investigate the internal probiotic, that's the probiotics encapsulate in the board, the crystal board. And the stuff A reflects the external probiotic conditions. And you can see a shelf life of 21 days, and there was no significant difference, and with the encapsulation probiotic crystal balls in living probiotic yogurts. And all treatments show the growth in the first 7 days, and then decline after 7 days to 21 days. But the reduction is very slight. You can observe the total number of the probiotics. It decreased only 0.5 logs, and which shows the crystal balls part doesn't affect the external yogurt's probiotics content. And then we also investigate in internal probiotic conditions. The level of live bacteria in the two types of crystal balls remain basically unchanged during the shelf life from 1 to 25 days. And with a decrease of a loss only less than 0.1 logs, the probiotic bacteria in the crystal ball were fully protected and did not leak to the external environment. And it proves the probiotic bacteria might stable in the crystal ball for a long time. That's because the shelf life of yogurts is about one month, so you can preserve for the whole lifetime of yogurt. And finally, we'll give a summary as the take-home message. And firstly, is orange crystal ball yogurt contains up to 40 million of probiotic. And the phase 2 clinical trial indicated this probiotic play important roles of decreasing the blood lipid content. And almost all probiotic can be preserved after the bile salt and the stomach acid. With the encapsulation, only a slight reduction occurs. And the encapsulation method can extend the shelf life of internal probiotics significantly, with only less than 0.5 log reductions up to 3 weeks. And that's all the content in my presentation. And thank you for watching. And I will give my special thanks to Dr. Qingmin Li and Liu Hope Dairies and DT. Do you have any questions?
Okay, thank you, Dr. Chen, for excellent presentation. If you have a question, please, for the audience, please leave your question in the text. And I think it's very interesting product, and I wish like in US we can also taste it. And sounds like it's very special like technology. And I'm just curious about Dr. Chen for the structure or texture of this crystal ball, how it tastes like, and also what would be the application pH in terms of besides this high acid yogurt, what else can we apply? Can we apply into a pudding product or other format of product? Thank you.
Okay, thank you for sharing this question. This is a very interesting question, and because I represent Qingmin Li and the Liu Hope Dairy R&D team, So I can only give the general answers from my perspective because I didn't do the research in person. So according to their description, it's a very texturized yogurt, so you can taste the crystal ball. And I don't have any detailed information about the pH and the formulas in application. I will ask the MT and get back to you afterwards.
Got it. I understand. Thank you, Dr. Chen. Yeah, I think it's very special product and highly recommend who can buy this in China. Please go ahead and grab it and let us know. And I think always good to see the companies, dairy company using innovative technology to do more product innovation and renovations. With that, if you're for continued interest, please leave a message in the textbook, chat box, and Dr. Chen will answer it. And also right now, it will be our door prize time. Let's see who got the chance
Recording stopped.
to win this opportunity of a 1-year membership. So I already said all the registered name here. So, and let's start. Okay, I would like to congratulations to the following members and non-members who just registered, and we would like to thank you for your participation. And after the meeting, we will reach out to you and also, thank you for joining this symposium. And with that, I would like to officially thank you for all the speakers today who have gave fantastic talk. And also, thank you everyone who still stay with us. And it's a great pleasure, to learn a lot more about the food and nutrition. And we wish that today's talk will inspire you or give you some idea in your daily life to apply a healthy life and more nutritious food, and or some research collaborations that which we hope this platform can provide you to reach out to the professors or research scientists to to reach out and do more collaboration work. And also we would like to thank you for the students who participate this events, and I think you guys have a lot of opportunities and gave a lot of us like a more learning from you guys, and we wish you guys have a really good a future in terms of study. And please don't hesitate to reach us, and you are very welcome to join NACAN. And within that, I think we will close the symposium of section 3, but however, it's not the end. And we would like to invite you to either turn on your camera, have a chat or networking section, because a lot of NACAN members here, we have our Professor Guoxin Chen, and we have our President Jinrong Zhou, and we have, yes, please wait turn on your camera. I can tell a lot of our NACAN members are here. And we will have a network section. Professor Zhou or Professor Chen, would you like to give some talk, comments?
Jinrong, go ahead.
First, 我们可以 switch language 是吧 ？Is that OK？ 首先非常感谢 Shelly 过来，这个是 professional 这个主持啊。就非常感谢，当然还有那个方勇教授，谢谢你们的这个特别精彩的这个主持了，其他的，另外的话，我想就是说，我想我们大家的感觉都是一样的，这些 graduate student 真是非常棒了。当然就是说有些就是很多程度上是因为这个名师出高徒啊，尤其我们这个 国勋同志的话，这是没话说的。所以我想他们应该真的就是就像谢磊刚刚说的，就通过就是这个 networking 和这个NACAN 这个一起大家进行交流，那么我想可能就是说对学生的这个成长，不管是 professional career 还是他们的 personal life 这些方面，我想都是 beneficial 的，因为就是说很多我们可能都经历了一些，那么可能有些方面呢，可能通过一些这个交流以后呢，对他们还是会有所启发，就是说，所以 again 欢迎这个尤其是这个 student 能够加入这个我们的这个society。
曹东应该讲两句。曹东今天忙了3个小时，完全没有停止啊。
首先就是我还是想说，非常感谢这个 session 的主持人就是 Sherry 啊，还有这个方教授，这个也是这个主持特别好，也不多讲了，刚才就有说了。那个呢，首先呢，另外还要说一件事，就是有点抱歉哈，因为这个 Zoom 有些 technical 的 issue， 就是我们用的另外一个 account 呢，就是它也不允许，就是只能允许2条线的就同时在我的账号上。那么第3条线呢，就必须要单独的开，所以当时就是江湖救急，这个主席就是闯3个红灯，江湖救急，就是把这个后来这个在第3场这个峰会场呢上做的也是特别的精彩，而且呢，这个它的内容也比较丰富，讲的也有深度，在应用上呢也很有意义，所以呢，这个整个呢就是开场上呢有一点惊险。有一点这个确实有点紧张，有点压力，但是过程下来的还是非常的顺利，而且这个杂志社呢，就是孙勇老师他们那边就整个团队哈也是非常给力的，就在整个协调上，都是工作做得非常的好，所以这个就是让我们赶下来，就是觉得用一个词来说，就是感觉应该讲，我觉得还是很震惊或者是很震撼，就是说。弄得还是尽管有些惊险，但是弄得还是非常的顺利。所以呢，我想说的就是感谢。那么现在是 network， 我想说的就是大家没有说话的，就是请就是 please speak out， 就这是一个非常好的一个机会，大家相互的交流、相互的沟通，就是 please do so，don't hesitate。好吧，我就说这。
我觉得首先。要感谢每个人参加的人，然后呢，主持人，我们这个会的以及其他的都很好。我全程听了这个主会场的和3.2的第2个那个关于precision nutrition and food safety 那个主持人都很棒，而且呢，很有趣的是，他有些人他这个有人说中文，有人说英语，他有的就是用英文准备的，所以都说得很好，而且。都做得也很好，东西很多，我觉得这个看到这些成果吧，或者说是他们的研究成果，我觉得这个目前的中国的这些学生学者做的东西，这个已经是非常好的了，非常非常好。然后我们希望能够进一步或者将来呢有更多的机会。邀请这些在其他会场没有做这个 webinar 的人，没有在这组会场的人，有其他的机会来做一些 webinar。所以我觉得我们有一个丰富的 pool 去找，比方说食品安全呐，以及这个他们的这个有肠道菌群，也有这个 precision nutrition， 以及这个 bioactive compound 各种各样的。所以我们不仅仅是通过这个认识了很多人，也拿到了更多的 potential 的 future 的 topics， 这是我的想法。
对，特别好。然后我们现在还有这个 Dr. Let me try to find the full name。
赵林
在上面，然后小青也在上面，蔡小青，然后。
I believe
潘老师也在，
对，袁翔也在。袁翔为什么不把你的头像那个呢？
推咖啡去了。
我们还有一位英语English speaker 他有问题是 Is there any common social networking group for communications?
Let me see.
And Dr. Hack, would you like to unmute yourself or feel free to turn on your camera? And we will switch from Mandarin to English if you would like to join our communication. Otherwise, feel free, to leave your email or reach out communication information. We will reach out to you after the symposium. Thank you. 对，我们在线的主要还是我们这个说中文。
我在点这个 ask 他 unmute， 但是他似乎没有反应。我看一下有。
看我们现在还有46位，就是你看大家好多都是。
大家就随便交流吧。
对，大家头像也没有显示，这个也没有 unmute， 就是这个就是我刚才讲的，就是我们就是希望大家 speak out， 就是这样才是一个 network， 否则就成了我们几个在上面说，大家在上面听，这个意义就更重要的就是我们相互有交流、有反馈、有这个response， 这样的才是一个就是 mutual 的这个怎么样去就是 benefit， 或者是说有的时候可能 opportunity 就这样来的。
Okay, Dr. Hack, is that right? Can you talk?
Yeah. It's me, Dr. Ijazul Haq from Pakistan. I am an assistant professor here in the University of Haripur, Pakistan. And I am really happy to see all the experts from my field, as I am more interested in public health nutrition. So I got a lot of, people from that area, and hope we can start some collaboration in future, and maybe start some studies here in developing countries like Pakistan. So this is, really a good platform for that collaboration.
Definitely. So if you look at the symbol of the logo for the NACAN, so you can see a bridge. That means it is a platform to connect us, not just people in the North America, but actually we should say people over the world. So I think we have our previous current president and the previous or former president, they all here, so we share the same value. That is the same mission. So what we are doing now. So hopefully, so this provide an opportunity or a chance for us to know each other better and to establish the connection.
Yeah, exactly, sir. For your nice words, and hope in future we will do the same. Thank you.
Okay, thank you.
And best of luck for your next.
Okay, great. So Lin Chen, so can you please go ahead and speak out?
Okay. Hello, everyone. My name is Lin Chen. I come from China. I've come from Chengdu University, and now I'm a visiting scholar in Purdue University. 很高兴有这次机会，就是来到这边，就是参加这个线上会议，让我也学到了很多东西。然后我的在成都大学现在是我是有6个研究生在做一些肉制品，还有一些食品加工，就是生物活性成分这些相关的研究。然后呢，就是今天就在这里也看到了很多，就是专家就学到了很多东西。然后呢，也非常愿意在这里继续和大家进行交流，然后学习。我英语不太好，就是来了半年了，就是去年12月份过来的。然后今年要待1年，就是今年12月份准备回去，在这边跟着一个就是印度的老师做一些生物活性成分，就是花青素对肠道微生物肠道菌群，还有就是抗炎抗免疫就是抗结肠炎这些的工作。然后就是时间比较短，现在时间过得非常快，就已经过了半年的时间了。然后就是就很难得的一个机会，就过来，就是也非常
加入我们这个学会，这个 就是以这种和方式执行。我们这半年还有很多很丰富、很精彩的活动，希望能够就 stay with us。
好的，谢谢主席。
I think there will be no boundary for the collaboration.
Yeah. Even you after
outreach.
you return to your home university, you still consider with experience in North America, still consider part of us.
Okay, I would like to. Thank you.
That is great.
And also for Dr. Hack, you probably can ask more of your Pakistani friends, our colleagues, to attend future activities because you have connected to this society. And we serve the science, we serve the whole humankind, not limited to certain ethnic groups, or not limited to certain countries. There is no boundary for science.
That is a great point. Thank you. And also, I want to appreciate that very much. Ling Chen turn on the camera and speak out. So we have another. So Xiao Chao Xiong. Sorry. So can you please go ahead speak out? If you speak English, Chinese, whatever you want.
对，我就说中文吧。Yeah. 我是那个华盛顿州立大学的 assistant professor。同时呢也 run 一些 startup company。但是我的 major， 我是刚刚在那个微信群里看到。觉得挺有意思。我的 major 是所谓的 synthetic biology， 可能跟 Shelley 旭在那个 multi-food 有点像啊，就是我们过去呢做很多 biofuel 啊这些东西 renewable chemicals， 但是发现非常难的做到 economy。现在的我们也做一些 plant-based meat 等等 carotenoids 这种 nutrition product， 但是我们肯定很困惑嘛，说这个东西到底会不会被大家 accept， 或者说从这个 food functional 来说是不是很有意义的？所以我们看到这种carotenoids, lipid, bacteria， 我们都非常的 exciting， 就是说我觉得大家的 research 非常有意思，非常的别有洞天吧，别开生面，反正是非常的 diverse， 对我来说启发也很大。但是我肯定不是我们这种传统意义上的 food engineering 这种area， 希望有机会多多交流吧，谢谢大家。
感谢 Dr. 熊，我是之前是做那个方向，在 Motif 主要是做 Symbio， 对，
像那个 Perfect Day 对吧？它有很多做这种人造牛奶、酸奶的，还有一些 protein 的对吧？包括甚至这种这个昆虫蛋白呀等等，对，都非常有意思。
欢迎。
Hello， 大家好。我叫张天欧，我现在在University of Texas at San Antonio 做 assistant professor。我的专业可能和大家可能有点不同，我是 kinesiology 专业，我主要做exercise and sports science， 主要做体育运动生理方面。但是我主要做的是运动营养方面的相关研究。
我可以加一句吗？就是你说的，你和我们专业其实 sports 和我们这个 nutrition 非常的紧密。在我们学校，我们这个 graduate program 非常多的 professor 都是来自 kinesiology， 而且他们当时学校 reorganize most of them they want to join nutrition. Sorry, so please go back to you.
就是我们做的有一部分是做 nutrition， 但是很多还是做training 或者是 exercise physiology， 可能这个方面，但是很多相关的 physiology nutrition 也是做很多 physiology 的东西。但是我的主要做的就是 exercise sports nutrition， 像这些dietary supplements， 之前主要做 phytochemical supplementation。研究主要就是做 skeletal muscle， 因为我们做运动就是做 skeletal muscle 相关的，主要做muscle inflammation。我之前做的 model 主要就是我做 human 可能做的多一点，也做过 animal， 做过 rats， 但是现在也是主要做 human。之前我们那个 model 就是想要研究这些 anti-inflammatory capacity of phytochemicals， 所以我们就用downhill running 做这种下坡跑的离心性运动，因为离心性运动可以造成 skeletal muscle inflammation。所以我们就用这种 eccentric exercise induce muscle damage。 然后补充，之前我们和那个 Quaker Oats、PepsiCo Quaker Oats 合作过，就是给他们补充那个燕麦的 Enzymatic。现在我主要做就是一方面还是做原来的这个，一个是燕麦的一个 Oats Enzymatic， 还有一个橄榄油当中的一个bioactive compound 叫 oleocanthal。剩下就是主要做一些 senior study， 现在就是 healthy aging， 就是怎么通过 physical training、exercise training 和 nutrition， to improve the seniors' physical function、physical performance。现在主要就是因为我现在 San Antonio 主要都是 Hispanic population， 研究就是 Hispanic older population， 希望以后能和专家老师有合作。然后我们可以在营养或者运动营养领域，就是营养很多我看到人做，但是可能做骨骼肌的相对少一些。我们主要做 skeletal muscle。如果你们有什么想要 test on skeletal muscle， 我都很开心帮你们 test on skeletal muscle samples。很高兴认识大家。
I think that's a good. Well, I'm happy that you attend this, and I knew what you are doing. I think I have some interest in terms of the glucose transporter in the skeletal muscle. You know, that's directly related to diabetes, right? And also, I'm not so sure the current GLUT4 theory is correct or not. That's another thing I would like to confirm, because right now, the current textbook saying that insulin stimulates GLUT4 translocation from intracellular location to cell membrane. But if you have human samples, I mean, have you ever checked GLUT4
expression of the
expression levels? I can tell you my personal experience. Okay, so I was interested in. I had one observation, which is that if I treat insulin and retinoic acid together, I saw a very quick glucose usage, massive usage in the L6 cells. L6 is skeletal muscle cells. And then what I found out is I tried to study the GLUT4 expression. I could not find a functional GLUT4 antibody to do the Western blot. I got my hands on almost all the GLUT4 antibodies and found out they actually detect a variety of things. So at the end, I have the overexpressed GLUT4 using adenovirus to really find out which is the correct band, which antibody really used is useful. I identified one, but that's for the mouse, right? For the rats and the mouse, and I'm not sure humans. So that's why I ask you, if you are interested in that, you have human samples, we probably can take a look at those.
We don't have human muscles because we didn't do muscle biopsy.
Okay.
We have rat muscle, we have mouse muscles, but not doing human muscle biopsy. That's complicated. You need like MD supervise, and you have to pay a lot to participate.
I agree. And also another thing is that how can you make sure that you really homogenize or solubilize all the muscle tissues? Because that's the one concern that I hesitate to do, to publish things, because many times it's very difficult to solubilize the whole muscle. That's the challenge I have. Yeah. And we certainly use Dance homogenizer trying to homogenize everything, but I still think I have not completely solubilized everything. They use Reaper buffer, and I'm not sure Reaper buffer is the best one.
Sure. I see someone is that comment for me. I don't know. 我在比较不同部位肌肉的差异。Okay. Sure. I mean, I would be happy to communicate because I taught anatomy before, so I know that muscles pretty well.
Okay.
Yeah.
So actually, in my college, I'm in nutrition department, but I have right now, my collaborator is from kinesiology department. So right now I'm looking at the vascular functions. We're looking at the 24-hour blood pressure. So yeah, so I think for some reason I actually have more collaborator in kinesiology departments. Yeah.
That makes sense. It's a kind of a transdisciplinary area. But in US, I don't see a lot of people specifically doing sports nutrition. Sports nutrition is pretty like.
What kind of testing are you doing? You said you're recently doing the human studies.
Well, we are doing, so there are 2 studies I'm currently doing, mainly working with the senior population. So last year we investigated this, the mind-body exercise. We investigated this Qigong, Chinese Qigong study exercise. So we designed like a 12 weeks Chinese Qigong intervention. Because here in US, we call them mind-body exercise. So we use that as a specific type of mind-body exercise, Chinese Qigong, for 12 weeks intervention. 五禽戏, I don't know how many of you. Some of you, if you are from Henan, you probably know 五禽戏. So we designed this 五禽戏 intervention in the older population. So we investigated them, and when we collected the saliva sample, we didn't collect the blood sample because this is more like a preliminary study. Because we want to take a look at how this exercise to affects hormonal regulation, chronic inflammatory markers like CRP, TNF-alpha, and also we look at testosterone, we look at cortisol level changes. So we want to take a look at how those hormonal changes or inflammation changes after this 12 weeks intervention. That's one study only having this exercise intervention. The other study is I'm currently working with a California company. I don't know if you heard Chromadex, but if some of you are investigating mitochondria, NAD, right? They have that NAD supplementation. It's called the nicotinamide ribocytes. So I'm designing a study to combine the nicotinamide ribocyte intervention supplementation combined with the exercise training together to see what is the individual effects and the combined effects on their physical performance and inflammation. So those are the 2 human studies that I'm currently doing.
So when you talk about physical performance, like what measurement you do, like what kind of testing?
That's a good question. We are looking at, so there's a specific test or a pool of tests. It's called, I think it's called HBBT, or what is that? Human performance battery. I can't remember the full name. It's something like a performance battery or something like that. So it consists of like 5 or 6 exercise measurements, like sit up and down in 1 minute, how many times you can finish, walking 6 meters or something, I think 6 meters, and how long it's going to take. So it's more like, and also the hand grip strength. I don't know if some of you have done that hand grip strength for both hands. So that's kind of evaluating your upper extremity or your arms muscular strength. It's more like measuring the muscle group's strength, both upper body and the lower body. But there's a group of exercises specific. That specific test is designed for older population. It's not a good test for like an athletic population. It's more designed for senior population. Yeah. And there are also some of the questionnaires like a pain scale after exercise, how you feel. So we combine them together to see if we are also looking at the DEXA. We use DEXA to look at fat mass and muscle mass, upper body and lower body. So that's kind of indicator how much muscle mass you can retain after exercise. But definitely we want to see if it's improved the functions, like walking distance. That's a key thing for senior population.
Very interesting.
Or anything we can collaborate, I would be happy to talk about it. Yeah. But this is a very informative session. I have attended the previous nutrition. I usually go to American Society for Nutrition annual meeting, and also American College of Sports Medicine. Those are the 2 annual meetings I usually go. And I know we have this like a Chinese. I mean, in the past, I know in the ASN we usually have a special session for this American, I mean Chinese Nutrition Society. But I mean, due to the pandemic, everything was online. This is my first time to attend this, so hope I will register. I will register this and then attend. Good to see everyone.
So we welcome you to join us, because in our organization right now, so we have expert in, nutrition metabolism, we have a clinical nutrition and, someone doing bench work, but we don't have anyone in sport nutrition. So you will be the one. So definitely will be, we would love to, join our organization.
Nutrition session, then I can bring in some of my colleagues. They are working on sports nutrition either in China or here. Then we can have like special. Because I know right now in China, I can't remember the name. The annual meeting from the Chinese Nutrition Society. They have a special session for sports nutrition. So I think we can also have this special session for our annual meeting here. I was actually introduced by a student of Dr. Wang Shu. Wang Shu's previous students in Texas Tech. I don't know if you know Yu Jiaozhu. She introduced me to this event.
Welcome.
Thank you so much. Great to see everyone.
Yeah, and I think you probably, if you went to the previous Chinese activity at ASN, probably you meant the China International Forum that was organized by this group, but under the ASN. Now this is our independent activity. Well, I think that Liu Yuhua is unmuted.
So we have Li Rongshen is turning on the video. Can you please speak out?
您好，老师，沈丽蓉教授是我们下午会场的发言教授，然后他现在来看一下会场的形式。沈丽蓉教授是我们的发言嘉宾，然后我可以给您介绍一下。沈教授，
非常感谢，非常感谢。
我在现场。
对对对。
大家好。我跟这里的主持人徐磊都见过面。这里跟陈教授在波士顿也见过面，在我们2018年ASMN 这个会议上是吧？有影响哦。对。
对，沈教授现在是我们浙江大学的，对，教授，您可以，谢谢。
你刚才也听了，我这几天都在听嘛。我们做的东西跟这个工作很多在美国波士顿哈佛塔夫茨这里，我做了很多年的就合作嘛。比如QQ 我们最近刚刚也发了一篇就 paper， 就是跟刚刚认为小年轻，我们的运动医学都有运动营养相关的。就我们比如用小鼠给它增肌，给它抗疲劳。那就发现了怎么我们突然之间的，比如叫热射病这些都非常有效的。那这些我们在做的这些结果，那都是在跟美国很多的有合作的。那我们用果蝇用 mice 用 rat 这些。现在我们还做到人群了，就是
看你有2个，沈老师，我看你有2个。
对，刚才我发现camera 不行，我又换了一个。现在这个已经出来了，好像。对对对。
一个叫沈丽蓉，一个叫丽蓉沈。
对，我就把它关掉嘛。对，刚才就不大好。
对，这样就没有回音了，效果就很好一些。对。
Hi, dear President and Dr. Chen. I'm Han from the Memorial University of Newfoundland, and my major is more like food chemistry and chemical engineering. So, and recently, I want to appreciate all the hard working and excellent presentations given by this society. And secondly, is that recently I received an email from the nutrition frontiers in nutrition to ask for as a guest editor. So I'm so wondering, like, what type of job and what type of duties is this position were responsible for? Yeah.
Johnny here.
Johnny can answer that.
Can you say something?
Yes. Okay. Can you hear me? Okay.
Yeah, sure.
So Han, I don't know if this is the two different matter or what. Mm-hmm. So you were invited to be a guest editor or review editor for the journal. Is that the Frontiers in Nutrition journal or what is
guest editor? Guest editor.
Guest editor.
Right.
Editor for a special issue or for a section or nutrition in Frontiers in Nutrition, a different section?
I think it's about a specific topic.
Oh, okay. So that's very common. This journal is very aggressive, going after active researchers, ask them to organize as a guest editor for a special topic, which is a special issue called special issue for other journals. So feel free to if you have time and you have interesting topic and you know this field or wanted to expand the field, you can come up with the special topic and take this assignment. But if you don't have time, feel free to say no. This is purely a professional development, professional service to the society.
Okay.
Yes, so feel free. This journal, I know if it's a Frontiers in Nutrition, Frontiers, this is the publisher. They are very aggressive in soliciting researchers to be their guest editor, to be the review editor. Myself has been requested to, which I agreed to serve as their nutrition Frontiers in Nutrition, nutrition genomics section review editor, because I have not submitted to the journal, but I know they have a higher recent years. They're expanding very much, and they have a increasing impact factor. So eventually I said yes. That's the story for this journal. But the other issue, since there are a couple of active researchers, tenure faculties still present at this meeting, I wanted to remind everyone that for this fourth NACAN Summit, we do have a special issue organized alongside with this symposium. We have 4 major themes. One is emerging field. The second one is basic for mechanistic studies for nutrients for nutrition. The third one is today is about agricultural food production. And the fourth one is tomorrow is nutrition epidemiology studies. So any field, regardless you are presenters, you are speakers, feel free to submit to this symposium because you are inspired and you inspired by the presentations. You have a nice story to tell. You can write a review. You can have submitting your original research to the special issue. So this is a great time to meet new friends and be inspired by new ideas, and accepting the invitation to organize a research topic or whatever you do. Just stay active with the profession, with the society, with our society, and with the whole nutrition food field. That's what I wanted to say. I don't know if that answer your question, but I do encourage people, who runs independent research labs, or even the graduate students, and feel like your research have a clear message. Please go ahead and submit to this special topic alongside with our fourth Nutrition Frontiers Nutrition Summit. That's all I wanted to say. I hope I answered your question. Dr.
It answered a lot. And just one point, I'm kind of new and I'm not so familiar with the responsibilities of being a guest editor for journal. I think for different journal have different points. So
yeah. So just like any editors, for any journals editors, if you are asked to organize a research topic in other journal, this is called a special issue. You are responsible to draft a call to come up with a theme for people to submitting to this special collection, whether it be for example, my field is about nutrients, bioactive compounds, their effect on browning of white adipose tissue as a way as a novel target to obesity treatment prevention. For example, if I wanted to organize a special call on this topic, on this line of research, I can write something similar to write a call, emphasize the importance of obesity, emphasize the novelty of the browning effect, emphasize the new frontiers of nutrition, which, study the role of bioactive compound in this field in driving browning. I can write a call and work alongside with frontiers and nutrition editors. And then, I get usually once you write the call, you work with the journal, they will publish that, and you don't have to work this alone. You can ask a team, ask anybody your friends working in the same field, your collaborator working in the same field, and to work with you as a team. So then you can, you don't have to do everything yourselves. So as an editor, you're responsible to write a call, and then you work with the editors in the journal and publish this. And so you're waiting for someone feel interested in your call, they can submit to the special issue. So you receive their abstract, you approve their submission, and then what you need to do is find the reviewers to review their paper. So we're actually first just getting into our special issue with the journal. So that's pretty much what I have in mind. Of course, along the way, you can always ask for help. There are technical assistance from the publisher who can help you every step of the way.
Okay, thank you. Yeah, that's answered a lot. And thank you for Dr. Zhao and every organizer. Thank you very much.
Yeah, please stay with us. Make friends and feel energized with 10-hour events. Feel energized.
Right.
Just added a little bit more, Dr. Pan. And the most time-consuming thing, serving as a guest editor, probably right now is to find reviewers, because right now, you probably have to send out request more than 10 to get one back. Sometimes more than 10 you get 0 back. So that's the time-consuming thing.
I see. Okay. So usually like reviewers should be know by you or or know you. Right?
But the problem is you don't want to overburden those reviewers, because you can only have so many friends in that area, and sometimes you really rely on the system set up by the frontiers to look for the experts according to the relevant research topics, and they can rank them, and certainly you can find some, but a lot of times they don't want to review because they have a lot of things to do.
Right. That makes sense. Right. Thank you.
There's a person named OK.
I think I just left a message for Dr. Zhao. So for the special issue, will there be any like publication fees?
Yeah, there are publication fees. In fact, this journal has a fairly higher publication fees, what we call the APC. So maybe it's about $2,490 for ish. But we were able to talk to the journal, and they come up with different strategies that the PI can take advantage of. One of them is institutional subscription. Most of the institutions support open access publication, so they set up funds you can apply for once your paper get accepted. And the other thing is a couple of things for difficult countries, difficult PIs, they probably can apply for fee reductions, something like that. So there are a couple of things you can do that is offered by the Frontiers in Nutrition. But for our special issue, they were able to give us some discount. So we have not finalized yet. We're only start accepting submissions in the last couple, 1 or 2 weeks. Most likely, I have to talk to my talk among our editor teams to finalize what kind of discount. But most likely, the top 10 papers that we accepted, we're gonna give 10% discount for everybody who are submitting, who are accepted in the top 10 status. So the top 10 papers who get accepted probably will get a 10% discount. But our bottom line is this journal does not give you a lot of a discount.
I know that. Okay, thank you.
It's already 12:30 Eastern time. So anyone else want to speak out? So please do so. So we probably have 5-10 more minutes. So let's just conclude today's event. So please speak out. This is a great opportunity for networking.
想邀请一下方院长，也是我们 co-chair， 看他回。
就我刚才看到他的，就好像就在这里好。Please。
好了，非常感谢啊，各位这个专家啊，今天有这个机会跟大家一起这个学习。我主要是一个是在这个会场主持了一下啊，然后到另外一个分会场去做了个报告啊，所以在另外一个会场也客串了一下两边啊，就是有这个照顾不周的地方啊，请大家这个多多这个见谅啊。然后在这里的嘛，也特别感谢这个我们这个会议主办方啊，给我们这个南京财经大学这样一个机会，一起这个协办相关的这个会议的日程啊，也感谢各位这个专家特别精彩的报告，对于我们来说也是这个受益匪浅特别是在这个食品营养学的这个领域里面都是顶级的大咖我们这个食品科学与工程学院啊，就南京财经大学的食品啊，非常的特殊啊，就是以前的这个南京粮食学校隶属于粮食部的，就是1956年国家这个建了这个3所粮校啊，一个是这个武汉粮院，一个是郑州粮院一个是南京粮校啊，所以说这3个粮校呢是我们新中国这个自己创办的粮食学校，后来由于国家这个体制的这个改革各自的学校都进行了这个从原来隶属于粮食部下放到各个省人民政府所以到现在是属于这个国家粮食和物资储备局和江苏省一起共建所以我们的这个学科特色就聚焦在这个粮食的安全粮食的这个产后的储藏储备以及粮食的营养和加工这块所以在这块的话，我们也是致力于对这个粮食的这个的精深加工往后面和人类营养健康相关的这个产业链的延伸做了一点点的工作希望各位专家这个有机会都给我们指导我们这个学科方向的发展，也在这里特别欢迎各位专家和各位领导有机会来到南京来到这个六朝
古都啊，时潮都会的南京啊，来领略一下这个具有一定文化底蕴的南京这个城市啊，也来到南京财经大学啊，和我们进一步的这个交流。感谢各位专家，感谢。
方老师你好，我也是南京人，我的侄子，我哥的小孩也是从南财毕业的，现在在外面呢工作。以后有机会回南京，我希望能见面啊。
太好了待会儿我们加一下微信，是在这个
对，
加微信
可以，
太好了
对，到南京回家探亲父母一定要见一面。
我看这个会议的几位老师有好几个是南京的。
对，下次回去我们一块儿去。
去周老师，
真的，下次我们一块去到你那。
对，周老师是在南京大学念的大学本科，对，是个人。
那你这个组团过来，周教授来带队，我们立即欢迎的。
一碗鸭血粉丝汤就 OK 了。
好的，没问题。
南京大排档，
我们还有盐水鸭子。
对，好的多了。
所以这个 network 非常重要嘛，所以说这个会议是很精彩的，学术的，学完了以后呢，精彩的部分实际上还有一些就是在这个 networking 上。
好的，那鉴于时间关系，要不周教授，我们
这里可以休息了，忙了挺累的。
对，这种总结2句呗，我们明天再见。
我也要走了，明天还有8点。
对，明天早上有。薛丽啊，多保重 ，Thank you， 薛丽。
那就明天大多数我们明天再见，好的，
明天见，
好吧，国内就午安，好吧，
拜拜。